Let me find it real quick. Oh, why is the... There we go. There's one of them. I gotta update the thumbnail real quick because this is not the right one. I'll probably just use the same one that I used last time. Let's go with that. Okay. Monetization. No. Trying to fix the settings here for the people joining. The other thing I needed to do was check the dashboard real quick. See, as people come in. Ray Smith subscribed. That is from 3 days ago. Yo-Yo Music. Thanks for the subscription. Just trying to cover these didn't play live last time because these subscribers came in like while I wasn't live. That one accidentally played twice. John De Bruin. Thanks for the sub. Let me actually turn the light on over here. There, so it's actually a little bit brighter. And I think the only other one that I need to mention is Bobby World 999. Okay, so I don't know if the B650 boards are on Micro Center's site. Yeah, so it doesn't look like they're up yet. I do want to shout out Joey RKDP. Joey left a comment on the previous live stream mentioning that MSI did update their manual, or at least in the, I think it's the universal manual, the global manual, whatever it was called. Let me go find it again. Or let's actually go look at it real quick. That's AORUS Master. We don't need to see. Okay, B650 Master. Taichi. We don't need to look at the carbon Wi-Fi. Ace. Support. And let's go look at documentation manual. Multi-language. So apparently the multi-language manual, as was mentioned by one of the viewers. So right here. Okay, so it does actually it does show it. And this is interesting because it's almost like when I saw this earlier, I was thinking this it almost felt like I was like looking at the results from taking an exam almost. Where it's like when I drew out the block diagram on the previous stream. Let me go ahead and open that up again. Let me go find that. Okay. Is it this one? Okay, yeah. So when I drew this out, you know, like I was literally just going off of the data sheet and what was in the manual. I didn't actually know that the manual had the block diagram. But as one of the viewers pointed out, so Joey RKDP pointed out, and thank you for pointing this out or bringing this to my attention, the manual does actually have the block diagram. So it's almost like now I can check my answers and see how I did as though I was taking a test. So the only thing that was different, so the real versus what I thought it had, is if we zoom in here a little bit, let me just see, how does that actually look? Okay, that looks pretty good. So the chipset, the primary chipset, has the 10 gig LAN, and so what this tells me, because remember I couldn't figure out where the last two SATA ports go, like in my diagram, if I remember correctly. Yeah, I didn't know where S3, S4 SATA went in my drawing. So, yeah, what I ended up assuming was there must be some kind of either an as media or somehow they're using less lanes. And it turns out there really were only 2 lanes. They have to be only dedicating 2 PCI Gen 3 lanes to the Aquantia 10 gig on the primary chipset, because otherwise there's no way that that would work. Like it would be bottlenecked like so badly if it was done that way. So that's interesting to see. So the other thing too that I had wrong was, well, I got all the M.2s right. I said that there were 2 M.2s on the second chipset, and they're right there. So M2.3 and M2.4. That's exactly what I said in my diagram. So I got the numbering right. And, you know, that just goes back to really understanding the chipset. It really boils down to understanding the chipset and how the lanes are allocated. So, really, like, I would like to thank Tech Power Up, because that website's publication, an article from way back in May, earlier this year, I think it was like published May 5th or something, that article has a very, very good diagram for laying out what the chipset has. So it's very easy to refer back to that, almost like a cheat sheet, where you can use that to determine like what lanes are available. So the only thing that is different from what I said was I said that the Wi-Fi, the AMD Wi-Fi, the as media controller for the 2 SATA ports, I said that those were on the primary chipset, and it turns out they're actually on the secondary chipset. And what they've done is they moved that to the bottom to bring the 10 gig NIC to the top. But everything else is the same. And the other thing too is the Aquantia NIC is using 2 lanes, which allows 2 more lanes for the SATA. So instead of 4 lanes, it's 2 lanes. And if you do the math, it works out, because 10 gigabit per second is roughly 1.25 gigabytes per second. So we're within that roughly 2, it's like 1.9 something gigabyte per second limit for 2 lanes of PCI Gen 3. So it all works out. So it's nice to see this, because it really clears up a lot of confusion I had with where these two SATA ports went. So that's good to see. The other thing too is, well, I mean, the Ace is a really good motherboard. Like I was saying in the previous stream, I think this is the best overall X670E motherboard. Like, the only thing that this board lacks, and I said it last time, I'm just going to say it again to reiterate, the only thing that MSI's motherboards lack that the other motherboards have is Thunderbolt. So there's, or I guess I should say USB4, because you can't really say Thunderbolt because it's not really, you know, it's not officially verified by Intel. So if you don't have it go through Intel's verification process, you have to call it USB4. So MSI doesn't have that. You know, it goes back to the options, right? Like, what, I guess they all the motherboard manufacturers kind of did their research to figure out, you know, what was what were the features that the end users were looking for. And I'm pretty sure USB4 was one that came up a lot, but MSI didn't incorporate it. And it's going to be one of those things where you can probably try to install the add-in card in the by4 slot later on, but it might not be guaranteed to work because you won't have the Thunderbolt header. So Gigabyte will support USB4 via the add-in card. It does have the I think it's like a 5-pin header on the Master and the Extreme. I don't know about the Elite. It might have it, or it might have the older one. I can't remember. But the Asus has it, so the Extreme has it. I don't remember if the Crosshair has USB 4. But ASRock is really where it's at. If you really want USB 4, I recommend the ASRock Taichi, because the Taichi is it's like half the cost of the Asus Crosshair Extreme, and it gives you the 2 ports of USB 4 on the back. So that's pretty nice to see. So I think the only other thing I wanted to cover. So yeah, here's the thing, or I guess the diagram, and I should probably put this in the description of the stream, shouldn't I? So let me go ahead and do that if I can. Article talking about for reference, I do want to compare what the let's just look at Gigabyte let's look at this one, because they probably already have the manual. And the reason why I want to look at this one is because I want to see 2 things. I want to see the block diagram. So they give us the block diagram. It's basically everything now has to fit on one chipset. And the other thing I want to look at is an older motherboard. So let's look at an X670E AORUS Master, or let's look at an S570S. Let's look at the revised one. Let's take a look at this and see what this looks like. Let's see if B650 is more like X570, because I suspect that it is. Hopefully they have the block diagram, but Gigabyte's usually really good. Hey Joey. Hey, thanks for the heads up on that MSI manual. I was talking about that earlier. And we're kind of looking at that. So what I want to do right now is I'm looking at the old, like, last gen X570. I want to see how it compares to B650. So where's my B650? I need to bring this over here. Got lots of tabs open. Okay, so this is X570, right? So you have a switch, you have the X16, and this is PCI 4. You got M.2s. It looks like there's one M.2, and then you had another M.2 somewhere. Yeah, down here. So it's interesting. So Gigabyte, on the previous generation, Gigabyte was doing the same thing that they do on the AORUS Master, where they have a switch with a PCI Express or M.2. Or actually, no, I think they do this on the Extreme, not the Master. I think the Master doesn't. Oh no, I take that back. The Master does have shared resources. It has it. Let me find it real quick. So it's got them over here. So on the PCI 3 bus, they have a switch down here for 2 SATA or the PCI Express by 2, which is actually PCI Express by 1. So that's very similar looking to what they did on the previous gen. It looks like the ASMedia. They don't say what ASMedia controller that is. I wish they did, because that is probably the thing. So right now, the only motherboard that I don't have a block diagram for is Asus. Like, Asus is the only vendor that it's still smoke and mirrors to me as to how they're doing things, particularly on the Crosshair Extreme. I think I can figure out how the other motherboards from Asus work, but the Extreme is a special case because that one, and let me pull that one up, they're doing some really interesting stuff on that motherboard where it's almost like they're either bottlenecking the 10 gig NIC or there's something that they're doing to pull that off, because to me it just seems crazy. Like, let me go ahead and add the diagram I did for that one. So I think it's this one, yeah. Let me just bring that down. Yeah, so the Extreme is kind of weird. Like, I still don't know where those last two SATA ports go. But actually, you know what? I think I can figure it out, because MSI, from MSI's block diagram, we can conclude that they're using 2 lanes of Gen 3 for the 10 gig networking, which means Asus can do the same thing. So that means Asus, but see, I already did that. I already labeled them as an X2 on the Marvell controller. So, but that's on the PCIe 4 bus. But I don't see how it would work any other way. I still don't know where those last 2 SATA ports go on the Extreme. They've got the Thunderbolt controller, which I assume is wired to PCIe Gen 3 X4, because if they put it on the Gen 4, did I say Gen 4? I meant Gen 3, because if it was on Gen 4, if it was over here, it wouldn't work, because where would this go? And we know from the manual that this is X4. The other thing too is the Gen Z 2x4, like that NVMe could actually be up here, and the PCIe could be down there. So either way, like, I won't actually know. I'm just kind of guessing. I have a 50% chance of being right and a 50% chance of being wrong, just like I was with MSI. Because with MSI, the only thing that was backwards was I thought that the Wi-Fi and the the SATA. I thought the Wi-Fi and the ASMedia controller for the 2 SATA ports were on the primary chipset, when it turns out in reality they're actually on the secondary chipset. But yeah, it's almost like taking an exam and then looking at the actual answers to see what I got wrong. But it's cool. You know, I've never had to do this before, because typically with high-end, like X299, X399, all the older high-end desktop stuff from AMD or Intel they've always published this info. But for some reason, you know, this launch was very, very weird. They didn't have the motherboard that I wanted on launch day, so I wanted the Ace, and I couldn't get it because it wasn't in stock, and I didn't think to check, like, the following day, and it never really showed up on the website either. Like, Micro Center never really showed that they had them. I know they had them in certain stores in very, very few, like, very, very short supply. I'm talking, like, less than 5 motherboards for anything with the MEG line. So I don't even think they had any Godlike. Like, I haven't seen any Godlike SKUs pop up anywhere. Not on Newegg, not on Micro Center. Newegg constantly says back order. The other thing too that's kind of weird. So a lot of people are probably wondering why is the Godlike so expensive? I think originally the Godlike was supposed to be the only motherboard that supported SLI. Like, if you actually looked at if you looked at the data sheet before the actual launch, the Godlike did list support for Crossfire and SLI. It did say support Nvidia SLI and AMD multi-GPU. They have since removed that from their page, which is really strange, because if this was the only motherboard that had the SLI license from Nvidia, then that could be, in my mind, that could be the only way MSI could get away with charging $1,300 for this motherboard. But if they actually don't have SLI on here anymore, then this motherboard is just a complete waste of money, because the Ace pretty much does everything that this board does. And in fact, the Ace actually, as far as I know, I think the Ace has DisplayPort alt mode, And I don't think this motherboard has that. Yeah, I don't think the Godlike allows you to run a VGA signal out of the display port on the back. So if that's the case, if it doesn't have SLI and it doesn't have, you know, any display out for the integrated graphics, it makes this board really strange. And I don't really know who is the actual end user for this board. Like, who's the target audience for this board? Because the Ace pretty much has everything except that fancy little controller thingy that comes with it. This little USB remote control thing, which is kind of cool. I know Asus did that in the past on their Rampage and their Maximus boards, and I don't think Crosshair. I don't think they ever did it on Crosshair, not that I'm aware of. But yeah, like Godlike is, I don't know, it's kind of a name thing for MSI, but I just feel like Godlike and Extreme and Gigabyte's Extreme are all kind of in the same tier, but this time around the pricing is just all over the place, right? Like typically the AORUS Master, the Crosshair Hero, and the MSI Ace are the three like flagship rival boards. You use one from the MSI Z590 on the Ace. Oh, the little... So, wait. So the Ace came with one of those? The little USB remote thing? I didn't know the Ace had that. Typically, I always thought the Godlike had that. MSI has kind of gone through a sort of almost like a renaissance, like in a self-discovery phase. Because MSI has changed their branding a lot. Like, the tuner controller. Yeah. Because I know MSI used to have the M power and the X power. I think the X power was like the top of the top, which is basically what the Godlike is now. And then I think the M power was what the Ace has become. And then I forget what they had below that. I think it was like gaming X or gaming, and then whatever the chipset was. Because my first MSI motherboard was the Z87 GD65 gaming for Haswell. So that was 4th gen Intel. And then the one I got after that was the X Power. So the X370 gaming titanium that was for 1st gen Ryzen. But you know, this like Ryzen 7000, it reminds me of Ryzen first, like Zen 4. Zen 4's launch feels so much like Zen 1. And that's not a good thing. For those that don't remember Zen 1, that's not a good thing. Like, this launch is kind of buggy. You know, the BIOS, like, there's really weird things. Like, I don't think the initial post time taking so long is a good thing. Like, from a user standpoint, that doesn't present well. It doesn't sit well with me. The fact that if you clear your CMOS or your initial boot, you know, you're looking at like anywhere from like 45 seconds or more for the initial post, and I just don't think that's not a very good user experience. Now, if we're talking servers or workstation, then yeah, that's fine. And it's almost like this platform is trying to be a workstation, like kind of like a workstation, but it's really not. MSI Unify X came with the tuner controller, which I use. Oh, okay. Oh, you use it on the Ace. Oh, that's cool. So it does. Yeah. So it works on. The Godlike just has a nicer digital version of it. Oh, okay. Yeah, I haven't seen this board anywhere. But it just seems so redundant. Like it's disappointing, because if this doesn't have SLI, this doesn't justify the price at all. Like, for the Godlike, the Ace though, I think that's where it's at, because you know, like, everybody was saying that these motherboards were going to be very expensive. Prior to launch, you know, the whole public was being warned. Everyone was saying DDR5. Well, DDR5 already is expensive, but everyone was saying the motherboards are going to be expensive. Infinite streams. Hey, welcome to the stream. So, like this launch is really strange. It's like Zen 4 is just kind of weird because and it doesn't surprise me anymore as to why people didn't like go out of the way to line up at a Micro Center to buy this on day one. Because it's, I don't know, it's just kind of strange, you know, like it performs well. I do think the temperature, why does it say playback? What says playback? Are we talking about... I'm not sure what you're referring to. Infinite streams. Why does it say playback? I don't see... It says this is a live playback. No, this is live. Oh, it says this is a live playback? I'm not sure why it would say that. This is happening in real time. This stream should be live, not, it shouldn't be a play. Oh, unless you're buffering, or unless you're watching the stream from the start. If you click live on the video player on the bottom, it should be next to the play and the mute button or the pause button. You should see it. It should say live. If it has a gray circle, if you go ahead and click on the gray circle, it should refresh it to the current, and it should be a red circle. Yeah, it should be live. It shouldn't be saying playback. I think playback is like if you click on the timeline and go back. But yeah, like this launch is kind of strange. X670E is not for everybody. I honestly think like when the B650 boards come out. So I was looking at one over here. So let's look at this one. This is the B650 AORUS Master. So this one does have the block diagram. See, like this looks like last gen in terms of the layout of the motherboard. This looks like a normal motherboard layout. You know, like you have your CPU up at the top. You have your chipset down at the bottom, and you have the uplink lanes between them. So you have your PCI root hub, and then all your peripherals connect, whether we're talking PCIe lanes or if we're talking USB, because that's typically all that connects to the chipset. The chipset is basically just a chip with a bunch of connections for PCI Express or USB. It's literally that's all it is. And the funny thing is, so I can't keep on recommending people go look at this Tech Power Up article enough, because this Tech Power Up article basically shows how, like, what are the possibilities in the lane allocation. And the cool thing is it even shows you that there's a single USB 2.0 port on the CPU. And that is where the onboard audio connects. Like, almost all of these onboard DACs and audio, like integrated audio, they connect on this USB 2 port on the CPU. I have seen ASRock. ASRock actually connected their onboard audio for the Taichi on one of the USB 2.0 ports on the actual chipset. And the other thing, too, is, for those wondering, X670 and X670E is nothing more than two B650 chipsets. They're actually B650 chipsets, because it tells you right here, AMD B650 chipset layout. Well, we know from doing all the deep dive stuff on the previous stream that if you were to derive the block diagram by hand, the way I did in the previous stream, like I had to do it for ASUS and I had to do it for MSI. In the case of MSI, I didn't know that they published their block diagram in the manual, so thanks to Joey for pointing that out to me. But ASUS is still a mystery to me. They still haven't published a block diagram. I don't even know if they'll ever get around to doing that. But it's kind of weird that the largest motherboard vendor by market share doesn't give you that info. That just seems very off-putting and strange to me. So not too happy about ASUS. I feel like ASUS kind of, I want to say that ASUS almost priced themselves out of the market, but then MSI went and, you know, they're charging like $1,300 for the Godlike, and ASUS, the Crosshair Extreme is only $1,000, right? So this time around, ASUS is actually the second most expensive. at the highest end, or the flagship model. But I don't know. Godlike Extreme and the Gigabyte AORUS Extreme, I kind of see those as kind of gimmicky boards. But it's strange because the X670 chipset gives you so much connectivity that it's almost like, if there ever was a time for me to justify buying a Crosshair Extreme or an AORUS Extreme, it would be this generation, as strange as that sounds, because you do get a lot of connectivity in terms of what you can do. It does feel kind of like a Threadripper motherboard, sort of. I mean, there are some limitations, right? There's some resource sharing going on. If you connect, like your PCI expansion card slot, you might turn off a SATA port or 2 SATA ports or something like that could happen. And you wouldn't have to worry about that if you were on something like X299 or X399 or even like the current Threadripper 5000 series. So it's interesting. But yeah, these are really cool platforms. I guess, is anybody in next week? So I guess we can talk a little bit about what's coming next week. So next week is the GPU week. It's going to be GPU week of the year because we have the RTX 4090 launching Wednesday on the 12th, and then right alongside it, strangely enough, Intel's Arc A770 is also launching. Now, what I don't know is if the A750 is also launching, or if it's just the A770 by itself. I kind of think it's both, but I don't really remember. I didn't really look into it too much. But we only have, it's like about a half a week left to wait. Now, I personally am not going to bother with the RTX 4090, at least not initially, because I already know that it's going to be very hard to get. It's probably going to, if you're going to try to buy one online, you might be dealing with scalpers. I don't know if it's going to be as bad as the 30 series was 2 years ago when it launched, but if we go by the trends, the fact that crypto crashed, you might have a better chance of getting one, but still, like $1,600 is kind of absurd for a consumer GPU. I just want to throw that out there because that's very, like that's just way too much money for a GPU. Especially, it's not even a Quadro, or it's not even a professional card, right? Like, I think the Radeon Pro and some of the old like RTX A6000 or maybe not the A6000, but there was one of them that's cheaper than this RTX 4090, which I think is kind of crazy. But like a lot of people that want one, they have to potentially change out their power supply. They might even need to buy a new case for airflow reasons. So yeah, I don't know. I don't know how it's gonna do in the reviews. Especially, I think the biggest thing on my mind is rasterization. Like, how is that thing going to perform in rasterization? Is it going to be significantly faster than the previous generation, or is it only going to be like 40%, 50% faster? Because if it's only 50% faster, I don't know if it's going to be worth it. Because of the state that the economy is in right now, and the whole $1,600 charge, it's more expensive than 3090 was at launch by $100. But I don't know, it's more electricity. And there's that whole controversy about the 30 connect disconnect limit on the adapter cable or the power cable, and the fact that there's no ATX 3.0 power supplies that you can actually buy. I think Gigabyte has one. I think they're the only one, but there was somebody on YouTube who did review them. I forget what his channel was, but he did a pretty good review on the Gigabyte. I forgot what the model was. But he essentially said he didn't trust it. So even though they claim 10-year warranty, and I looked at it, and it looks really small. But Newegg's already sold a ton of them. So there's people out there that have those power supplies with the actual cable for the 4090. But I wouldn't run the 4090 off of one of those Gigabyte PSUs. I'm gonna try to get the Arc A770 on launch day. that's what I'm actually wanting to get, because I'm going to be doing a lot of videos on this channel covering Intel Arc A770. I don't know now. What I don't know yet is, and maybe the guys in the chat can help me decide on this. I don't know if I should initially pair the Intel GPU with my new Ryzen 7000 series desktop, or should I pair it up with Alder Lake? That's the only thing I don't really know what the plan is there. But yeah, I think I might pair it up with my 12700K initially, just for the initial test. Oh, and guys, let me know if the audio is too loud, or if it's too quiet, or if it needs to be adjusted, and I can do that, because the audio, I think in some of my previous streams, was either it was too loud or something like that. It's good. Okay. Yeah, but looking at the B650 chipset, this does look like this is probably gonna be what people buy. In fact, I would probably recommend the upper tier boards on the B650 over a lot of the X670 boards. I'm not saying the X670 boards are bad. I'm just saying if somebody is looking at adopting or upgrading to Ryzen 7000, regardless of which CPU you're considering, unless you really plan on using it like a, for either professional work or something along those lines, I really don't think X670 is really... I don't really want to recommend it for a gaming computer. I think it's not really... It's not a very good gaming platform. It's too much. It's too much money. There's too many components, and I think one of the reasons why the memory training takes so long is because there are so many chipset components internally that have to enumerate and initialize. It almost does feel kind of like Threadripper, because I had a Threadripper. This is actually the computer that replaced my Threadripper computer, but I did have an X399. It was an MSI MEG creation paired up with a Threadripper 2950X. That was a 16-core 32-thread. So it looks like I side-graded, because I traded a 16-core 32 for another 16-core 32. But, this CPU doesn't have the latency issues that Threadripper had, because the Threadripper that I had was it was like the Zen Plus Threadripper, which means that it didn't have the I/O die, and it had a lot of latency issues. So I ran it in NUMA mode, which is what AMD calls game mode, because that was actually faster for most things. Even in my case, production tasks seemed to work better even when it was in NUMA mode, as opposed to the default, which is UMA mode, or uniform memory. The only one, first time. Yeah, well, see, okay. Now you're getting into the whole, the boot time, the post time. Yeah, because here's the thing. So I am using a Gigabyte AORUS Master. And the thing is, the AORUS Master, I've ran into a lot of strange issues with the AORUS Master on launch day. So when everybody was saying that the initial post time is the long one, and then every subsequent boot from cold restart or warm restart shouldn't take that long, in my case, it was taking long. In my case, every time I had to reboot the computer, whether we're restarting for Windows updates or whether we're restarting for, like a capture card not getting detected and I have to reinitialize it by restarting the computer, in every single one of those attempts, the AORUS Master was doing the memory training. Every single time it was memory training, and I timed it. So I actually have with me here two different memory kits that I was using. So I have this XMP. This is a 64 gigabyte kit, so these are two 32 gig DIMMs. This is what I was using on launch day. This is not Expo rated memory, so if I stick this in the motherboard, it only recognizes XMP. There's no Expo profile. But this is 2x32, so it's 64 gigs, 5600 megahertz, cast latency 30, so it's got pretty good timings, and it's 5600, so it's I guess easier on the IMC compared to trying to run it at 6,000. And I haven't really bothered like overclocking the memory to try to figure it out. But the other thing too is Micro Center. So for those wondering, Micro Center was giving away free, like, well, it's not free. I mean, if you were buying a Ryzen 7 or a Ryzen 9 7000 series CPU, so that means the 7700X, the 7900X, or the 7950X, they would bundle a free, well, it's not, well, okay, it is free, because if you buy the processor, you get this added on for free. This is a $250 value, but on Micro Center, it's actually $189 was the list price for this SKU. This is a 32 gig kit, so it's two 16 gig DIMMs, and this is the G-Skill Flare X5. So this is Expo memory. It has the little AMD Expo logo on there. I don't know if anyone can see that. Okay, maybe you can. So right there. So this is what I'm running right now. And it works really good. I'm running it at the full spec, as well as the mem clock equals U clock. So those things are synchronized in a 1-to-1 ratio with this. Now, the interesting thing, if I try to use my 64 gig kit, I cannot run with the XMP profile. I cannot run in a 1-to-1 ratio. So my U clock ends up being half of my mem clock in order to run this stable without errors. So I have since downgraded myself to 32 gigs total using the one that came with the processor. But I do think that's a very good deal. I don't think they have the deal available anymore because I think they sold out over the weekend. Or I guess they ran out of inventory because it was while supplies last for this memory kit. So, but you know, it's like essentially a free 32 gig memory kit that has an Expo profile. So I thought that was a pretty good deal. But yeah, it's cool that they did that because I do think that at least in that initial availability window, that did help incentivize people to go and make the jump to DDR5 on an AMD platform, because they didn't offer this for the Intel Alder Lake series. But thankfully for Alder Lake, you know, you can always fall back on the DDR4 motherboards. The only problem with the DDR4 motherboards, so for those wondering, I do have an Alder Lake system. I did allude to that earlier when we're talking about ARC. So I might test ARC with my 12700K initially, and then I'll probably move it into the Ryzen 7000 series computer. But the Alder Lake, so I have Alder Lake on DDR4. So I'm using a Gigabyte Gaming X DDR4 motherboard, and the problem with DDR4 on Alder Lake, people think that, oh, it's more cost effective, so there's no reason to buy AMD or at least AM5 because I can just buy Alder Lake or soon Raptor Lake with a Z690 or Z790. The only problem with DDR4, and I'm saying this because I have a DDR4 motherboard with Alder Lake, is if you buy DDR4, if you pair Alder Lake with a DDR4 motherboard, you're basically being treated like a second-class citizen, because there are no DDR4 motherboards for Alder Lake that support that come with things like the postcode, the 7-segment debug display. So if you're booting up and you don't know why it's not posting, you have no idea, because I mean, I guess some of the boards have the little, you know, the 4 little LEDs, DRAM, VGA, CPU, and storage, I guess, or whatever the other one was. But you don't get the 7-segment display. So you don't get the little 8 and the 8 next to each other that show you what's wrong or what's the postcode number. Like, there's not a single Alder Lake DDR4 motherboard that comes with that feature. It's ridiculous. So that's what I mean by you basically are treated like a second-class citizen if you're on DDR4 with an Intel 12th gen. And I'm pretty sure it's going to be the same thing with Raptor Lake. So, meaning if you wanted a debug code motherboard, you were forced to go DDR5. And, you know, it's almost been a year, so November 4th of last year was when Alder Lake launched. The price of DDR5 at that time was double what it is today. And today, it is still roughly double what it is for DDR4. So, meaning DDR5 last year was like 4 times as much money as DDR4. Although I might be a little bit wrong there, because DDR4 might have also been a little bit more, or I don't know. I didn't really track DDR4 last year. But yeah, I mean, this launch has not really been smooth for me, at least, and that might be because I'm on AORUS on Gigabyte motherboard instead of one of the others. But going back to what I was saying earlier about the long post time, so I found out just yesterday that the way that you can skip the memory training after the initial post, so that every time you restart your computer, it doesn't have to do memory training anymore. There's actually a setting in the BIOS that I'm guessing that MSI and the others and ASUS have this set to enabled, because the AORUS, for some reason, on my motherboard, it would train memory like it was the first boot every single time. I had to wait like 45 seconds just for the post beep, and then I would be able to boot into Windows. So with the 64 gig kit, this takes about 45 seconds to post when memory training. The 32 gig kit takes about 30 to 35 seconds, so it saves like 10 seconds, at least on the Gigabyte board. But ever since I found out about that BIOS setting and I turned that on, now I'm actually a lot happier with this platform overall, because now it feels like it's supposed to in terms of how quickly you can boot into Windows. But I only learned about that yesterday. I didn't know that there was a setting that you had to enable in the BIOS, because I think the other vendors have that set to enabled, and Gigabyte had it set to auto, and for some reason auto wasn't doing it. I had to actually go in and set it to enabled. There was 3 options. There was disabled, auto, or auto, disabled, and enabled, and it was on auto, but it was always memory training. So yeah, I had to enable it, and then now it actually like skips the long memory training sequence. So this is the sort of thing that you have to deal with when you're an early adopter. It's like, these are the sort of things. It's weird because I went from being on a mature platform, so X570, to, you know, it's like I went back in time. Now it feels like I'm on Zen 1 again in terms of having to wait on BIOS updates. I think the other big problem that I've run into is with capture cards. So I have an AverMedia Live Gamer 4K, which I use with a PS5 for 4K 60 video, like pass-through or video recording. And that card works from a cold boot, but anytime I send the computer to sleep, or if I hibernate the computer, when I wake it up, that card is just straight up gone. Like the LED that glows with the AverMedia logo, that never turns on. It stays off when you wake the computer from sleep. And Rec Central, which is the capture software, I'll get a notification on the bottom right side of my screen that pops up. It says Live Gamer 4K disconnected, and it's straight up gone from the device manager. So it's like it was never there. So it's like the OS cannot even detect it. So it's meaning it's not even getting power through the motherboard. So there's definitely some kind of weird. I don't know if it's Gigabyte's fault or if it's an AMD Agisa thing. I tested another capture card, so I also have an older AverMedia 2, which is a 1080p 60 capture card, which is an X1. And actually, let me show you guys. We can show from the, if I still have the manual up. Okay, well, no, this is not it. I gotta go find the X670E AORUS Master. So let me just show you guys real quick how I have this connected. Yeah, I really wish I was able to get the Ace when I needed to, when I actually went to go buy the CPU, because I'm not so happy with this Gigabyte board. Okay, so this is how I have it connected. So the capture card that doesn't work, or doesn't wake up from sleep, is connected on the X4 slot down here. And it has to be, because it is electrically X4. It requires 4 lanes. The other capture card, the older one, is an X1, which means it's an X2. And it goes, I have it down here on the PCI 3 bus, and that one works perfectly fine. I can put the computer to sleep. I can wake it up. That older card always wakes up, never has any problems. I even tested the old card in the X4 slot, and it works fine in that slot. So I know this slot is not defective. So that rules out a physical problem with the actual slot. I can't test the card that doesn't work in this one because it requires 4 lanes. So this is the reason why I suspect that it might be an issue with memory stability, but I'm not sure I know how to prove that without debug tools. And the other thing is I really want to test this with another motherboard, like with the Ace or even an Asus board, because I think that there's a bug with the card having to travel through the 2 chipsets. I think there's some kind of like latency. It sends a signal but doesn't get the reply when it goes back to sleep. When the computer wakes up, you know, it sends the signal to wake it up, but either there's some kind of PCI loopback that's not working, and the signal like dies in the primary chipset or somewhere. It doesn't get to the CPU, so the board, like the capture card, doesn't reinitialize. I have no way of testing or debugging that. I have opened a support ticket with Gigabyte, and they keep on asking me stupid questions like, you know, well, did you update the BIOS? Did you, you know, reseat the card? Did you, you know, like all these type of, you know, things that I've obviously done. I mean, today I rolled back to the older BIOS because strangely enough, Gigabyte actually removed the latest BIOS from the website. I noticed that earlier today. So if we go to Gigabyte's website, we click on Downloads, BIOS. So originally there were 5 BIOSes available. So there was the launch one, some other one, and then this is the one that I downgraded to. So F7D, but they used to have F7E, and F7E was what I had been using since launch day. So on launch day, another funny story about what it's like being an early adopter. So the F5 BIOS, which is the BIOS that the motherboard shipped with, when I installed the capture card and I tried to turn the computer on the F5 BIOS, the PC doesn't even post. It doesn't even go past memory training. It has a postcode error 0D. 0D is the postcode error, and it doesn't do anything. It's just 0D, and that's it. So I turn it off. I take out the capture card. I turn it on. Then it goes to code 15. So now I know I'm good. And now we're gonna memory train. We're gonna get into Windows, and that worked. So then the first thing I did after that was I updated the BIOS to F7E, and that one works. I mean that one boots with the capture card, but when you go to sleep and the computer wakes up, the capture card's gone. So that's the problem. So I thought maybe I should downgrade it, because the thing is, the F7E BIOS had AMD AGESA 1003. It was 1003A was the AGESA version, and strangely enough, they've removed it from their website. So I don't know, maybe they've found some serious issue. So when I saw it was gone, I was like, okay, I'm getting off this BIOS. So I downgraded to F7D. So I'm back on 1001. I tested the capture card. It behaves the same as the F7E. So it posts, the capture card works fine, but then if you put the computer to sleep and you wake it up, the capture card's gone. So same problem. So yeah, you know, now I'm on the older AGESA. From what I can tell, the performance is the same. So I don't know what's going on. I'm pretty sure there's a long laundry list of bugs that they need to fix. But that's why I was really hoping that there was someone else out there that had any capture card that was a by4, or any kind of add-in card that is, you know, by4. I know MSI has the expander with the Ace, but that's a little bit different because that's an X8, which means you need to plug that into the chipset or into the CPU, because that's gonna go to that's gonna connect here. That's where you would plug in the expander card, because it's a by8 card. So you bifurcate that for X8 X8 or X4 X4. The reason why I really want the Ace is because I suspect that if I had the Ace, I would plug my capture card in on the bottom PCIe slot down here, which is a by 4. The difference is on the Ace, my capture card goes straight into the CPU. Whereas on the AORUS, you know, we're going through the chipset. We're actually going through... wow, we got a lot of these open. We're going through 2 chipsets. We're going through the primary and the secondary. And I suspect there's a bug with Gigabyte's implementation, and, you know, it's one of those things where I either have to wait on them, so who knows how long it's going to take to fix that, or I could just go with a different motherboard and completely sidestep the issue and solve the problem that way. But that's a very, very expensive fix, because I'm talking about having to buy another motherboard and then figure out what I want to do with this one. So, yeah, that's kind of a headache. But these are the sort of things that what it means to be an early adopter. And that's why some people completely refuse to be the beta testers for some new product. I don't know. This year's a strange... This is going to be the year of, like, half-baked products. Return it? Yeah, I could do that. I could do that if I can get the Ace within the return window, is what I'm saying, right? Like, I think, yeah, I could do that, but if it's past the return window, then I can't. Then I'll probably have to sell it to somebody. Or just keep it as an extra or something. Or like a test bench platform or whatever. That's the only problem. I don't know. It's very disappointing, to be honest, because I have a feeling that if this PCI Express thing is not going through the chipset, I probably don't have a problem. I really wish there was somebody that had like a Taichi or a Steel Legend or like one of the other vendors that's not MSI, because I assume MSI will work because it's going through the CPU. But like ASRock, for instance, wait, why does it keep on? There we go. Like ASRock, this is the Steel Legend. So this one, for some reason, ASRock, I don't know how they managed to do this, but they have a, why does it say Gen 3 by 4 going to the CPU? This would work because the capture card is PCI Gen 2 X4. So it's 4 lanes of Gen 2. So that's all I need. So the Gen 3 will work fine. But it looks like ASRock has a by 4 CPU connected expansion slot that might work. I have a feeling it's a bug with the chipset. So it's probably going to need a firmware update. Now, the thing is, if it's an AGISA problem, worst case scenario, it's an AGISA problem, because AMD is going to be really, really slow to roll out an AGISA update, because AGISA updates take a long time to verify and fix all the issues. So if that's an AGISA problem, I'm pretty much screwed, because there's probably not going to be another AGISA update until, you know, at the earliest, probably the end of this month. But if it's a Gigabyte problem, then hopefully they can fix it pretty quick. But their support doesn't really seem like... I don't know. Like, I've gone back and forth with their support now on this issue, and they keep asking me, you know, like, have you contacted AverMedia? And yes, I have. I have a case open with AverMedia and Gigabyte, and AverMedia seems like they're trying to help me more than Gigabyte. So AverMedia has actually, you know, they told me to download hardware info, send them like an XML export so they can see how it's connected internally. George's Micro Center has one Ace. Oh, really? Man, that one, like, see what I mean? One. that board is so hard to find. I knew that board was going to be so hard to find. Because, seriously, MSI has really stepped up their game. What state am I in? I'm in Texas. So, Georgia's going to be a long drive. So, but yeah, no. I have to wait for the Dallas store to get one. I'll have to wait for the Dallas store. But man, that's... such a bummer. I mean, honestly, it's not a terrible situation to be in, because I don't always have to use the capture card. it's one of those things that's just really annoying, right? Like, if I want to turn on the PS5, because typically I never use the PS5 without my PC. If I'm going to play a PS5 game, like for example, Forbidden West, the only way to play Forbidden West is to play on the PS5. So what I do is I fire up my PC. I could open OBS or XSplit, but I typically I don't use either one if I'm just going to play the game. I would open up Rec Central, which is Aver Media software, just full screen it, and I can see the game, 4K, 60 FPS. The capture card supports HDR, all that jazz, and that's typically how I use it. But now it's one of those deals where it's like, I always let my computer go to sleep. I don't shut it down. I just make it go to sleep if it's idle long enough, it just goes to sleep. So it's one of those things where it's like, if I want to turn on the PS5, I have to restart the computer. And the other thing too that I failed to mention earlier was sometimes when I reset the computer, the capture card doesn't reinitialize from a warm restart, which means I have to restart it another time. Like I have to double restart and then it comes back. So it's just really annoying. I don't know. I don't want to say I hate Gigabyte because this is a new product, so I'm going to give them the benefit of the doubt. I just hope that they can fix the issue within a month. Like if this goes beyond October, I don't know. Next time I have to buy a motherboard, they're probably not going to be on the short list. Because a lot of people have been saying a lot of bad things about Gigabyte. There was the whole fiasco with the power supplies. But that has nothing to do with motherboards, and then people were saying that their graphics cards are not so great. But I figured, well, the motherboard should be fine, right? Like, what could go wrong? Because I remember when I went into Micro Center, I wanted to get the Ace. Now the website did not say they had the Ace. There was no listing of the Ace on launch date. But I went up to the sales guy and I was like, "Do you guys have the MSI Ace in stock, the new X670?" And they're like, "We don't have any MSI." Like, the reply to me was, "We don't have any MSI. We've got Asus, ASRock, Gigabyte, and that's it." And I was thinking to myself, that was a facepalm moment, right? Because that's like, I drive all the way to the Dallas Micro Center, and the one brand, it's like, okay, there's four. Okay, technically, if you count BIOSTAR, there's five, but we're not going to count BIOSTAR. There's four brands, right? Out of the four, the one brand that I want is the one brand that they don't have. They happen to have all three of the ones that I don't want. It's such a facepalm moment. You make the holy pilgrimage to Micro Center, and it's like they don't even have the motherboard that you want, but they don't even have the brand that you want. Like they didn't have any MSI boards, and I was like, "Are you serious?" MSI's launch date was a day later. Yeah, I don't understand why. That's super annoying. Like, the one thing you like about Gigabyte is their motherboards. Their motherboards are cool looking. Like, when I knew I couldn't get the Ace, man, now I almost think, like, maybe I should have just not even bought Ryzen on launch day. The more I think about this, the more I get flashbacks of the whole, like, buying process. Because it was one of those things where, luckily for me, I did my research ahead of time, so I had a backup plan. Like, I knew I didn't want to get Asus. I know I didn't want the Crosshair. For multiple reasons. One is it was too expensive, like $1,000 for the Extreme, and the other thing was the Crosshair Hero doesn't have the PCIe lanes that I need. Like, there's actually no, there's literally just the X16 and the X8, and they're shared, and there's no buy 4 slot. There's a buy 1, but that's not going to help me because I need a buy 4 slot. And they don't. The Crosshair Hero doesn't have that, and it's a $700 motherboard that doesn't have that. I was like, really? So that's a deal breaker. So the other one that I probably should have gone with was the Tai Chi, but actually now I remember the reason why I couldn't go with the Tai Chi. The reason why I couldn't go with Tai Chi is because right here, you can see it doesn't have the third PCIe slot. But if it wasn't for this one missing thing, I feel like the Tai Chi is a really good motherboard. Like, this motherboard, for $500, it pretty much gives you everything except that expansion slot, because you're getting USB4, you're getting the Thunderbolt controller, the Intel Thunderbolt controller, not the ASMedia one, but the Intel one. And they've done a really good job. Like all the layout on the Taichi, the documentation is excellent. ASRock actually has the best, most comprehensive block diagram. They tell you if it's a front panel header or if it's a rear physical port on the motherboard. Like, they tell you if it's an ASMedia, they tell you which controller chip it is. You know, the Intel NIC, the USB controller, Maple Ridge. They tell you everything. Like, ASRock's documentation is spot on. Like, really, really good. It's funny. It's like ASRock has the best documentation, and Asus, being number one, has the worst documentation. Really strange. Really strange. But this product feels half-baked. Well, okay, I won't say that. It's not that bad. Intel Arc, based off of what the reviewers are saying, that feels half-baked. But this feels like they cooked it in the oven long enough for consumption, but I think they should have put more seasoning on it. It's like it needs some updates. So, but yeah. At the end of the day, though, it's I don't care about the 95C thing, because, you know, there's like another thing too where it's like people saying that, oh, it runs hot. If you look at the performance, though, the increased power consumption is justified, but the 95C thing, I can see why a lot of people don't like that. But the reality is, you got to look at what you're actually doing with the CPU, because if you're just playing games, this thing's never going to get anywhere near 95 Celsius. There's no game that's going to cause it to run that hot. Like, you have to be doing production workloads to ever see it go to 95C. And I'm running this off of a Noctua NHD15 air cooler. And I've done extensive testing with gaming, and it never gets over like 75 Celsius. I think the hottest I saw it get was close to 80. But it does that in spikes, right? Like, it does it in spikes. But it's typically like 73, anywhere from like 55 to 73 is kind of the common range while you're playing games with this thing on an air cooler. And I'm still seeing the full performance because the game is not always loading all the threads, so you're still hitting the 5.5 to 5.7 boost clock on various different cores on different threads depending on what it's doing. So yeah, I'm satisfied in terms of the processor and the performance that it brings. I'm just not so happy with the user experience on the motherboard side, and that might be because I have chosen one brand and my experience might be completely different from someone else on a different brand. So, but it sounds like in Joey's case, because props to Joey for mentioning the Ace motherboard block diagram was in the documentation earlier, but I assume that the experience on the Ace is probably more positive than the experience on the AORUS Master. I'm not trying to hate on Gigabyte, I just know that this is a new platform, so I expect bugs to exist in the firmware, but, you know, I really want to see some forward movement on the support team side in terms of cranking out fixes. Whether or not Gigabyte can do it, at least it would be nice if they could communicate to me whether they acknowledge that the bug is with Gigabyte's firmware or if they acknowledge that it's an AMD Agisa problem. It would be nice to know that and not be left in the dark guessing. I had the Gigabyte. Oh, yeah. Yeah, and the thing is, the Extreme, when I was at Micro Center, they didn't have the Extreme. When I was in Micro Center, I think they had 5 or 6 AORUS Masters, and they had a bunch of the Elite AX. You picked the Ace. Yeah, that's what I was thinking too. The Ace. So here's the interesting thing. So the only thing, I don't know if you were watching the stream when I was saying this earlier, but early on in the stream at the very beginning, I think one of the first things I was saying in the first 5 minutes of the stream going live was MSI is the one brand, like MSI is the one vendor that made motherboards, like, and when it comes to X670E, MSI is the one. Let's actually go to the let's go to this MEG series. Let's look at the Ace real quick. Let's look at the Ace. So MSI is the one vendor that when I was evaluating the different motherboards to figure out which one fits my use case, MSI was the only one that when I looked at the motherboard and I looked at what it had, I thought to myself, this is actually a motherboard. When I would look at the other motherboards, like for example, let's go look at the Tai Chi. Well, this is a Steel Legend, but the Steel Legend actually looks like a motherboard. But let's look at AORUS, maybe? I like how their marketing is so, like, over the top. A new era is coming, daybreak hour. Like, what does it have to do with the motherboard? I mean, it looks cool, but, you know, like, this looks like a motherboard because it's got the PCIe slots. But when I saw the Crosshair, you know, it's got the 16, the 8 that splits that one to 8, and then it has like a buy one, and that's all it had. I was like, what kind of $700 motherboard is that? Like, it doesn't even have an X4 expansion slot at the bottom. Like, what is that? Like, what is Asus doing? So, in my mind, when I saw the Ace, I was like, or even the Carbon Wi-Fi. Like, these are actual motherboards. These have expansion slots that actually are usable. They're not these useless X1 slots. Like, for example, Gigabyte gives you it gives you 3 X16 physical slots, but the bottom one is only an X2, which is basically an X1. Like, what am I gonna do with an X1? What X16 card am I gonna put in there that only operates on one PCIe lane? Like, that's completely useless. You can't run an M.2 off of that. You're not gonna run Wi-Fi because it already comes with Wi-Fi, so that's redundant. It's never gonna happen. So it's like, what are you gonna do? That slot is basically useless. The only thing that actually goes in there is like a legacy capture card, like my old AverMedia card that only does 1080p. Like, that's the only thing that would go in there. I guess you could put a DAC in there, but most of the good ones are USB now anyway. So it's like, you know, that's so dumb. But I guess the downside of MSI, the trade-off rather, is that MSI is the one vendor that completely ignored Thunderbolt and USB4. Everybody's like, Thunderbolt, 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 USB4, USB4. MSI's like, now what? What now? Like, they didn't even catch the memo. You know, everybody was screaming USB4, 40 gigabit per second, Thunderbolt 4, it's coming soon. We need to be ready. And then MSI's like, whatever. We're not gonna do this. We're gonna give people expansion slots instead, and they can plug in whatever they want. So I think they did it right, but I do understand that for production use cases, some people want USB 4. So I get that. So if you want USB 4, MSI unfortunately is not going to be a good fit because none of the MSI motherboards have USB 4, and by the same token, they do not have Thunderbolt. If you want Thunderbolt or, well, USB 4, then you got to go with the Tai Chi from ASRock, which is probably the most cost-effective one because it's $500, and that gets you your 40 gigabit USB on the back. There's 2 of them, plus there's like an internal header. So you get lots of Thunderbolt on the Tai Chi on the cheap, because if you don't want ASRock for whatever reason, then the only other option is Gigabyte and Asus. Now, Asus gives you the USB 4 ports just like Tai Chi if you're okay with paying $1,000 for the motherboard. If you're okay with spending the money for 2 Tai Chis to get 1 Asus Crosshair Extreme, then you can get Thunderbolt on Asus, or you can get USB 4 on Asus. Now, I think the Crosshair has one USB 4, but I don't remember. I mean, the Crosshair Hero, the $700 Crosshair Hero might have it. Actually, we can check. We can check. I don't think it does. I think it's 20 gig like everybody else. But I know the Extreme does. So let's see. If it has USB 4, I'll be surprised. So, and then Asus's site is doing this retarded thing where it's like I scroll a little bit and it like skips all the way down. Okay, so it does have it. So right here, 2 USB 4 with the Intel controller. Okay, so it's just like the Tai Chi. So it's like if you want Thunderbolt but you don't want ASRock, or I mean if you want USB 4, I keep saying Thunderbolt but I don't really care. If you want USB 4 but you don't want ASRock because for whatever reason you're an Asus fanboy or you just think Asus is better because of RGB or whatever reason, and you're okay with spending $200 more, then you can get the Crosshair Hero. So I guess that answers that question. So yes, the Crosshair Hero and the Extreme have USB 4, but if you don't want to spend that much money, then the Tai Chi is probably the best fit. But just know that you're not going to have any buy 1 or buy 4 PCIe lane or expansion slot. So that's the only drawback with the Tai Chi. So it's what's cool about this, and why I think I'm doing such a deep dive discussion in all this, is because I hope this illustrates that never have we had a situation like this where there's so many different motherboards that are so expensive, and everyone's complaining about them being so expensive, but from the different offerings from the different vendors, they're so different in how they've implemented these motherboards. That's what makes this so fascinating to look at, because MSI completely ignored USB 4 and made a bunch of traditional high-end motherboards, one being the Ace and the one being the Godlike, and then even the MPG one's pretty good. But then Tai Chi or ASRock and Asus went all in on USB 4, and they bought up those Intel Thunderbolt controllers and they put them on the boards, and you're like, here we are, and we're going to charge you a lot of money for this. Gigabyte took a different approach. Gigabyte did things a little bit different. So what Gigabyte did, and this might be why, it doesn't really make much sense why the Gigabyte Extreme is $700, to be honest, but what Gigabyte did is they didn't give you the ports on the board, but they did give you the Thunderbolt USB 4 header. So if we look here, wait, am I looking? Oh, I'm looking at the wrong one. Close this one out. It has to be the. Why are there? Is this two of the same? Here it is. So this is the Master, right? Yeah, this is the Master. So this is the board that I have. So right here, I want to draw everyone's attention to this. Thunderbolt USB 4. There's the header. So it does have the capability of supporting the Thunderbolt add-in card, which you'd have to plug into the PCIe X4 slot. So in my case, I'll never use it unless I stop using my capture card, because the capture card currently goes here. So that's why it's one of those things where it's like this board. Ultimately, I chose the AORUS Master over the Tai Chi because I didn't need USB 4. I actually needed to install a capture card that uses 4 lanes, and I didn't want to run my graphics card at by 8, if that makes sense. Because the cool thing about Gigabyte is there's no sharing of bandwidth. This graphics card slot is the full 16, and it's always 16. It will never be cut in half from any random peripheral being connected down here. This is connected to the chipset. This is also connected to the chipset. So there's no sharing of the CPU lanes. The CPU, like Gigabyte went with, I give you 16 for your graphics card, and I give you 2 M.2 PCI Gen 5 M.2s. So right here, 4, you add them up, 16 plus 4, and 4, that's 24 lanes. So that's your full PCI Express 5 bus. So Gigabyte is doing it pretty nicely, because when you look at this, if you want to do RAID 0 or even RAID 1, you can actually RAID Gen 5 SSDs off the CPU when those SSDs are available. So that's really, really nice. So it's not like the AORUS is trash. It has, they went with a pretty good approach for a prosumer kind of configuration, where if you want to do RAID on here is pretty solid, because there's no weird like sharing. You have full resources, full Gen 5 lanes for those two M.2 slots. So that's really good. The Ace can only really do that for Gen 4 because the Ace has two of them like down on the bus over here. So it's interesting. So the Ace is pretty good for RAID as well, but in terms of the total throughput, the AORUS Master, when it comes to like file, like queue depth and that sort of thing, the AORUS Master is going to run circles around the Ace if we're talking storage. So there's like a plus and a minus for all of these different boards, which makes this very, very interesting for someone who's like an enthusiast or like a tech nerd and likes looking at like PCIe lanes and USB allocation. So fascinating stuff. So if we go look at the Ace, so the Ace, you get one. Actually, no. Wait. Yeah, you get one. You get one. You always get one. So you get one Gen 5 SSD off of the Ace, but that's all you get for Gen 5 connectivity. All the other M.2 drives are Gen 4 down on the chipset, and two of them are on the second chipset. So there's a little bit of additional latency there. Not that matters too much, but you know, if you're doing RAID, like a RAID 0 for these two is not going to be as fast as a RAID 0 on the AORUS. Number 3. What's 3? You're talking about these? You're talking about these M.2s on the chipset. Oh yeah, you're right. You're right. You have the expander card. That's true. You can, yeah. But the thing is, the only thing with doing what you're referring to is that is going to cut your graphics card down to X8. Because if you want to use the expander card, you have to plug it in here on the second PCIe slot, and that's going to make your graphics card run at an X8. So I consider the expander card, it's good, but it is going to take away lanes from your CPU. Not CPU, excuse me, the GPU. It is gonna drop your GPU down to X8. So in that regard, there is sharing of resources, or it forces you to have to reallocate resources. So some kind of limitation there in terms of what it's doing to achieve that. But yeah, that's true. You can do that. But yeah, you do have that option, and that's why I would rather have the Ace than have the Master. I do agree the Ace is a better motherboard overall, so I can see why they justify charging more than what Gigabyte's charging for the Master. Honestly, the one that doesn't make sense from a price standpoint is the Extreme. The Gigabyte Extreme doesn't really seem like... Let's actually look at the Gigabyte Extreme. Is this the... No, this is the Master, so let's just Google it. So let's look at this one, because this one's actually interesting. I have a feeling if I bought the Extreme instead of the Master, I probably wouldn't have the problem, because as we'll see, the block diagram on this Gigabyte board is different from the Master. The Master and the Elite are actually more similar in their overall layout than the Extreme. The Extreme is actually quite different, the way they've allocated stuff. So here's the Extreme. Unless you just go with one. Yeah, you could do that. But then you're tying up the X4 slot. Typically for me, I wouldn't want to put an M.2 in the expander slot. The X4 slot is what I would use for like a capture card, or maybe like a 10 gig SFP plus NIC that's fiber based or something, or like a DAC or something. Well, actually the DAC would be better off in a by 2. The PCIe slots are not good. Not sure what you mean by the PCIe slots. Oh, you mean on the Gigabyte? Well, see, the difference is it's the way they've done it differently. Like the way I see it, MSI prioritized PCIe slots, expansion slots. Gigabyte prioritized M.2 storage, when it comes to Gen 5. That's the only difference. Like MSI is giving you the expansion slot for Gen 5, and you're free to do whatever you want with it. So in that case, it's more flexible. Whereas Gigabyte went all in on storage. Like, we're going to give you 2 M.2 Gen 5 SSDs, and there's no sharing of resources. So, but if we look at the Extreme, so this is the AORUS Extreme. So this is their flagship. This one is $700. So you can see they've implemented a switch. So this one, let me see. So there's, okay. So there's only one 16 slot. This looks a little confusing because it makes you think that there's another slot. There's actually no other 16 slot. So what this is it's either 16 lanes to the GPU, or you have 8 to the GPU, and then you have 4 to 2 M.2 slots. So actually, what the Extreme... Okay, this is actually interesting to point out. So, because we just talked about the expander card that MSI gives you. What Gigabyte has done on the AORUS Extreme is they have effectively given you the expander card, but they have integrated it into the motherboard. So what I mean by that is your second and third M.2 slots on the motherboard take lanes away from the GPU. So as soon as you plug in a M.2 drive in the second or the third, that will automatically make the GPU run at X8, and it'll take 4 lanes from that 16 lane allocation to power up that M.2 drive. Interferes with the active GPU backplate. Gigabyte interferes with the active I don't know about that. I don't have any issues with mine. You know, I was actually afraid that my Noctua D15 wouldn't fit on the AORUS Master because that Gen 5 M.2 heatsink is super tall, but it fits no problem. The other thing too that I will point out, you're saying that it interferes with the active. So, but you have to remember that Gigabyte has the button. Gigabyte has the quick release button, just like Asus. They basically copied Asus. So my master board and the Extreme board has that button to press to release the GPU. I'm surprised because typically, I think when they were designing these boards, they would have made sure that the backplate isn't affected. Because there's certain height tolerances that they have to match. Oh, the M.2 heatsink is in the way. Well, I don't know about that. Because I have the Master, and as far as I know, both of them have the same... They both have that really, really tall heatsink. Yeah, they both have the same... It looks like it's the same height. I don't know. I don't have a problem with mine, and mine has a backplate on it. But the thing is, let me go back to the... Where is the diagram? We have too many windows open. So, but see, okay, here's the thing that I wanted to point out. So, this right here, this switch with this 8 and 4 and 4, this is effectively like the MSI expander card being installed, except doing it without the expander card. So the Extreme is kind of equivalent to the Ace, and that's why they're similar in price. It's just a little bit different because this one you don't have to install the expander card. But the other thing too that's different here is you do get a PCIe 4 slot, but the difference between this and the Master runs this expansion slot off of the second chipset, whereas the Extreme runs it off of the primary chipset by itself. So I wonder, I'm curious to know, like, if I had this motherboard, would this motherboard have the same problem that the Master has, where when you wake it from sleep, the card doesn't come back? Like, I think because this is going through one chipset and straight up to the CPU, I almost bet that this one would not have that problem. I bet there's some kind of bug going between these two chipsets that they have to fix. Oh, GPU water block active. Oh, you got one of those. Okay. Yeah, I'm not doing any liquid cooling. All my GPU has the stock air cooler, and I'm using a Noctua D15 air cooler for the CPU. I was afraid that the Noctua wouldn't fit, but in my case, it fits. It looks pretty close, but it does fit. Actually, I might be able to show you guys. Well, let me see. Let me see if I can move this. See if I can bring this down. Show you guys. Maybe it won't work. Oh, maybe it will. Okay. All right, so here is. You guys not be able to hear me that well because I'm having to step away from the microphone, but I'll show you the computer. Actually, let me full screen this real quick. I gotta find the camera. Hold on, where is it at? Alright, chat's not gonna show up, but I never peeled off the glass. So this is a, well, here's the computer, and the camera's not doing a good job focusing. Let me see if I can get another light, because it's really dark. Hold on. Okay, well you can see there's the Noctua. You can see postcode EA, which means that I have woken it from sleep. And it has the weird, like this is what I mean. I think there's like a resume bug with Gigabyte's UEFI. But you see there's a GPU. See, it's a close fit though. What else did I want to show you? Like, you can see the memory. So I'm not big into RGB. There's the AORUS Master, like on the I/O shield. You know, there it is. This is this default. I never bothered to customize it because I can barely see it because the Noctua is so big that it just blocks the whole, like, you can't really see anything, right? That's the only downside of going with an air cooler that's a giant dual fin stack. Alright, so anyway, that's it. It's in a, and those wondering what type of case this is the Fractal Torrent, the mid tower. Alright, let me go back so the chat can show up again. Okay. Let me put this back. Now I think the camera might be all messed up in terms of where it was. Okay, I actually had to move the whole thing. Okay. But you can see, like, when the computer cold boots, it has the code AA or A0. But when I wake it from sleep, it always ends up with EA, which if you look up that debug, it stands for S3 resume boot script error. So I think there's a bug with the UEFI. And I think if they fix that S3 resume, S3 is basically sleep mode, for those that don't know what that means, but it's referring to the sleep mode. So basically when Windows goes to sleep, I think it tells it sends something to UEFI. I think it writes it into memory. And then when you wake up from sleep, I think the UEFI is supposed to go, like, load it basically does a load to get Windows back up, and it's basically pushing everything that was in that script file. But for some reason there's an error or something, and it doesn't do it correctly or some weird thing like that. I don't know. I don't know. That's why I really think I need to get, like, at least access to another motherboard to test. That's not a Gigabyte board, because if it's just Gigabyte, then I think most people are probably not having these problems. But I can't imagine that Gigabyte's the only one that has all these weird issues with the BIOS. So, but they did remove the F7E BIOS from the website, which makes me wonder, does ASUS still have theirs? So if we go to support for the Crosshair Hero, driver and utility, BIOS and firmware. So no, ASUS has still got it up there. Beta BIOS version 1003. So Gigabyte removed their 1003 patch A from their site. Like, you can't actually download it anymore. Does the Extreme have it? Nope, they removed it from all of their... Yeah, something's going on with Gigabyte. I guess it's probably a Gigabyte problem then. Because does MSI have it on here? I think MSI is actually behind. No, never mind. I take that back. 1003. So they're the same one. So Gigabyte, for some reason, removed their beta BIOS for 1003. So maybe they think this is an Agisa problem. ASRock? ASRock has 1003. So Gigabyte is the only one that doesn't have the 1003 update BIOS anymore. And these are all beta BIOSes. So I just want to reiterate that we are, if you're running Agisa 1003, you're on a beta BIOS. You're not on an official BIOS. But you know, my PC won't even post with the capture card installed if I was on the original launch day BIOS. So fun times being an early adopter. So let me see here. What was the B650? Yeah. So see, I think this is why I'm probably going to only recommend B650 for people who want to build a gaming PC and they want to go with the new Ryzen CPUs. I recommend that. It's one chipset. There's way less components that could go wrong. Like, there's way less point of failures in this setup. So it's more simplistic. It's more like an actual chipset mainstream motherboard that we're familiar with. This looks like Z570. This looks like Intel Z670. So yeah, I mean, this looks like, you know, your expansion slots are all in the chipset here. You have, yeah, so it just, I don't know. Yeah, I don't know. The only other one I was thinking of was the Extreme from ASUS. This one does check all the boxes. It has the by4 slot. It has all that stuff. The only problem is I don't know how they're allocating resources. Right? They're bring this back up, or wherever it is. Extreme. Okay. So this is what I think the ASUS Extreme, how it's laid out. I don't know if this is right. But they have something. They have like some kind of ASMedia chip that I don't know about, or they're doing something like spectacular with how they're able to get all this USB4 and all this extra connectivity and a 10 gig LAN and a 2.5 gig LAN. Like, it's crazy. I did all the math. I tried to compute it all and draw it out for people to see what the block diagram looks like. I couldn't figure out where those last two SATA ports go. Same problem I ran into with the Ace. But the thing is, this is more confusing because this has more random stuff on it. Like, it's got this Intel Thunderbolt controller for USB4. And this is technically USB or PCI Gen 3, 4 lanes of Gen 3. But the thing is, they could actually do this on 4.0. I don't know why they would, but that's like ASRock actually has this running off the CPU. So Asus can't do that because Asus has this Gen Z2 add-in card that mounts vertically next to the RAM, and that gives you a Gen 5 SSD in addition to the natural M.2 one on the board. So it's just like the Gigabyte board where you get two M.2s that can run at Gen 5 natively, so you can RAID these two together if you wanted and get very, very good throughput. They have a switch though for their other M.2, which will force the graphics card to run at by 8, and it will force the second X16 slot to run at by 4. So it's not that big of a deal, but they've allocated it in a strange way. So the cool thing about the Extreme, the Crosshair Extreme allows you to add an expander card like the MSI card in the second slot and run it at 8. But you cannot use this M.2 drive if you do that. So it's one or the other. So there's a lot of, I don't want to say limitations, but the only thing with the Asus Crosshair Extreme is there's a lot of resource sharing. So meaning you can do this thing, but then you can't do that thing. Like there's a lot of that with this motherboard that I think is probably going to catch some people off guard if they go and install a bunch of M.2 drives and they wonder why is their graphics card running at by 8. And if they plug something into the by 8 second slot, they aren't even able to use half of those lanes. So there's a lot of gotchas that I think can confuse and frustrate a lot of users with this board. And a lot of those answers or a lot of those problems could be avoided if Asus would publish the actual official block diagram in their manual. Because this is the most mysterious motherboard. Like it's so hard to figure out what goes where. My thoughts on this are just looking at it here. Yeah, I can't figure out where these go. I don't know where those go because they have to be running their network stuff off of the Gen 4 bus because there's not enough lanes on the Gen 3. Gen 3 only has 4, and they have to have 4 SATA drives, and they give you 2 more SATA drives. So where are those going to go? Unless they're running a bunch of ASMedia controllers, which I don't think they are, because if you're running an ASMedia controller, you can't do RAID 0, and they say that you can do RAID for 4 out of the 6 SATAs. The remaining two, I don't think you can do RAID. I have to double check, but I think they're running off of an ASMedia controller, but I don't know where that controller goes. Unless they're doing some weird hocus pocus with USB and somehow converting USB lanes into SATA. So I think you can do that because external USB drives, you know, it's mapping a storage drive, but I don't know about that because that might not even be using SATA. So I don't know. It's weird. They show up as SATA drives though. If you say in the manual that they're SATA drives, then they can't be USB, at least as far as I know. So yeah, this is probably the most interesting motherboard because it's got a lot of connectivity. It's got USB4. It has a lot of expansion slots, but it's really, really expensive. But this is probably, out of all the motherboards, this is the one that I think does it all. Like, the only other one to look at is, let me think. The only other one to look at would be not this one, the Godlike. Let's go back to Godlike. I want to see the block diagram on Godlike. Because what's actually different? I have a feeling this is going to be more simple than the Asus. Because this is the same as the Ace. So I have a feeling this is probably going to be just like the Ace. Except they're probably doing something different with the USB. There we go. Okay. So the difference is this does give you a 2.5 Intel NIC in addition to the Aquantia. So the Aquantia is taking up 2 lanes. That could be 2 lanes of Gen 3. This is taking up all of the Gen 4 lanes. And this is taking up to, okay, so see, the math adds up. 4 PCI 4 out of 4, so there's no more 4 available. This takes up 2 PCI 3 lanes, and each of these SATA drives take up 1 PCI 3 lane. So if you do the math, remember there's 4 available. So 1, 2, 3, 4. So there you go. That's all your primary chipset. And then you've got 3 Type A's, 4 2.0. That's fine because I think you have a total of 6 that can be like you can drive 6 USB 2 off of this. They're driving 1. Okay, they actually wire the audio DAC to a USB 2.0 port. Remember, there's 6 of them available in the chipset. They give you 4 via a front panel, so they give you number 5 for your audio, and then number 6 is actually not wired to anything. And then you have this. Okay, that makes sense. And then okay, it is worth reiterating for those that are wondering, all of the advertised USB Gen or 3.2 Gen 2x2, aka the 20 gig USB ports. Every 20 gig USB port on X670E is always going to be off of the chipset. It's never going to be off of the CPU. The one exception is the Asus ROG Extreme, which I believe uses I gotta go back and look at my picture here. The Extreme, if we bring that back up, the Extreme is doing... Was it the Extreme? No. I think it might have been Taichi. Was it? Oh, no. Was it? Oh, no. I take that back. I'm mistaken. It was the Ace. Was it Ace? Hold on. Was it the Ace? Ah, it was the Ace. Okay. So the Ace has an ASMedia 3241 ASMedia controller hanging off of the PCIe 5 bus for a 20 gigabit USB port. Now, the thing is, this is like a splitter, or this is probably a switch. So that means, yeah, that means the Ace has a resource sharing situation here. So that bottom PCIe slot, if you plug something in to the bottom PCIe slot, you cannot use the Type C on the back, the one that is slanted. So the one that is on the very top of the I/O panel, that one shares bandwidth with the PCIe slot, and the PCIe slot has priority. So if you plug in an expansion card in that bottom slot, whatever you connect to that USB port isn't going to work anymore. It's going to get turned off. The ASMedia does not have priority. The slot has priority over the ASMedia controller. So that is something to point out on the Ace. So, see, this is the sort of stuff... Now, I was able to derive that myself, interestingly enough, if we go back to my drawing from yesterday, before I knew about this. I just want to kind of show that again. Is it this one? Yeah. So this is me manually trying to figure it out on my own. But I did actually try to illustrate it up here. See? So I did draw a switch. And there's your bottom PCIe slot. And there's your ASMedia with the 20 gig USB. So in some cases, you can get 20 gig USB off of the CPU lane, the CPU bus via PCIe 5. But they have to go out of the way and wire an ASMedia controller to enable that. So in most cases, this is not how it's going to be. Like in most cases, it's actually going to be the way it's done here, where it's actually going via the chipset. Which is strange because the 10 gigabit USB-C is almost always going to be off of the CPU. And that one is going to be the one that can support DisplayPort 1.4 or DisplayPort Alt mode. So that one is the one that gets to be wired to the internal graphics. But if we go back to the Godlike, so the Ace does have this ASMedia. Does the Godlike have that? Okay, so the Godlike has the same thing. So the Godlike also has that ASMedia with that extra 20 gig USB-C on the back. And then, so here's the thing that's really strange. So the Godlike is $1,300, and the Ace is, I think it's like $700-800. This gives you DisplayPort alt mode, so you can have a display out off the integrated graphics. The Godlike is more money and does not have any way for you to make use of that integrated graphics. That is really, really strange. They don't have any video out capability for the onboard iGPU. That is very, very strange on such an expensive motherboard. So this is what I mean by, I don't really know how this is going to be able to like compete with the ASUS Extreme. So there you go, you got 10 gig, that's 2 lanes of Gen 3, there's your other Gen 3, there's your one Gen 4. Because remember, there's 12 PCI 4 lanes per chipset. So, but you have to count your uplink. So 4, 8, and your downlink, 12. So we're out of lanes. So that means everything else that's going to go off of PCI 4 has to go off the second chipset. That's why you tend to see more stuff just crammed onto the second chipset. Because this one has 4, and then you have 8 more. So you have, where is it? So right here, these two. 4, and then another one, 4 more. So 4, 8, 12. That's all your PCI 4 lanes. That means that everything else that we're looking at is either USB or it has to come off of the 4 PCI 3 lanes. So this is one PCI 3 lane. This is one PCIe 3. Oh, okay. One PCIe 3 lane, and they're doing 2. So okay. So the Godlike is actually using another as media. 2, 4, 6, 8. Oh, so that's how the Godlike is able to get 8 SATA drives. They're using a second as media controller. But does that mean, okay, this is one lane. This is another lane, so that's 2 out of 4. And then I guess this is 3 and 4? No, because this is another lane. Oh, so there's probably going to be some bottlenecking on the storage side with this this set of SATA drives here. So I would recommend, if somebody is actually going to buy the Godlike and use it with the storage, if you're going to plug in a bunch of SATA drives, especially if they're going to be like actual SSD drives and not like spindle drives. If it's spindle drives, it doesn't really matter. But if you're going to connect a lot of drives via SATA, one thing you want to keep in mind, what I would recommend is P3 and P4 should be flash drives. A1 and A2 can also be flash drives. And then and any of your spindle traditional magnetic drives, plug those into the B. So B1, B2, B3, B4, you can put these on the mechanical legacy drives, because those, who cares if those bottleneck, because they're already gonna bottleneck you anyway. So yeah, because you essentially 4 drives are sharing one PCI Gen 3 lane, and typically the way you're supposed to do it is 1 SATA drive per Gen 3 lane. So the way most motherboards are doing this, if we look at this is the AORUS Master, so this is the board that I have. So if you look at it here, see, 4 SATA. So this is eating up all of the PCI 3 bandwidth off of the primary chipset. All the drives, all 4 of them mapped to all 4, 1 per drive, 1 lane per drive. So this is the way that AMD wants you to do it in terms of the way they design the chipset. But if you want to try to dense pack drives, you have to use an as media controller, which is what they've done on the other board. So in this case with the Godlike, you know, you're using an as media. This is the reason why having the block diagram is so valuable to somebody who is doing a lot of work with large files, someone who needs to know how the storage is going to map out if they're going to do RAID, you know, all that kind of stuff. This is why this is very, very important. And now that I know this, I think I found my answer to ASUS. I think I know how ASUS is doing that with those drives. I think what they're doing is exactly what MSI is doing with the Godlike. They have an as media controller connected to a single PCIe 3.0 lane, and they're stacking 4 drives off of it like this. So now I think I finally figured it out. So we learned it. We learned the answer to the ASUS Extreme by looking at an MSI Godlike block diagram. That's ridiculous. Wi-Fi 6E is one lane. 2.5 gig LAN is one lane. This is the third lane, and this is the fourth lane. So there you go. That's all the connectivity. So this one's pretty straightforward. Now that we know that, let me go back and look at the Extreme again, because I think I know the answer now. So for the Extreme, that means that they can do... Yeah, what that means is that right here, this is actually... Yeah, the only difference is now they're doing... I think they're doing two as media. So basically... Wait. This is going to be, I think, 1 or 2. I think you got to do 1, right? Because it's as media. So 1. And then you've got 2 SATA. 2x SATA. But then you have to also break this up. So this would have to become 1 lane. I think you got to do 1 lane off of this guy. And then this is going to be different too. This is probably going to be like, we got 2 via as media. So we can do 2 via as media, and then we can do 2 alpha as media. So they probably have a third as media controller. There's probably 3 of them. Which means that... Oh, actually, you know what? They can do 2... Yeah, they can do... Oh, okay. Okay, I think I figured it out. So basically what they're doing is... one... It's 1 per set. So it's like... There's 4 lanes total, right? So they've got 2 drives natively connected per lane. So we'll just say SATA. And then here, instead of it being like 2 drives, well, it's actually 1, 2, 3, 4, 5, 6. Because I said it was 4 plus 2. There's 6 total. So 2 and the 2 over here. So this is as media, and it was like ASM. I forgot what the number was, but as media, and then 2 SATA, and then the same thing over here. You got as media, and you have 2 SATA. That's how they're doing it. That's the only way it'll work on the Extreme. You're building your first PC, and this is how meticulously I approach technology, understanding the motherboard. Yes, it's very important because a lot of people overlook it, and that's the thing. You're spending a lot of money on one of these X570. Because see, here's the thing. Here's the thing. X670E feels to me more like it feels more like a prosumer, almost like a replacement of Threadripper. I don't want to say it's a direct replacement of Threadripper. When you look at how much the platform costs, the fact that some of these motherboards cost more money than the most expensive AM5 CPU. So the fact that the ASUS Extreme, which we have derived this block diagram for, this motherboard is a $1,000 motherboard. This thing costs more money than the 16-core CPU that you would pair this up with, right? Because it wouldn't make sense to pair this motherboard up with the 8-core or the 6-core. You know, that just wouldn't make sense. It doesn't compute. Why would you pair a $300 CPU with a $1,000 motherboard, right? So what that means is that you're going to have to spend a lot of money if you're buying if you're going to go all out on a motherboard like this. You might as well buy the highest end CPU. I think possibly I could see someone running the 12 core off of this thing, like the 7900X. But if you're spending $1,000 on a motherboard, like at this point, you might as well spend the extra $150 and get the 16 core. lane allocation and utilization of resources. Yeah, that's exactly what this is about. Because the problem here is I feel like the reviewers, the media, all the YouTubers, the tech tubers, and AMD themselves, and the motherboard manufacturers like Asus, Gigabyte, MSI, ASRock, I don't think they marketed this product correctly. If it was me, if I was the product manager at AMD, I would have set the narrative a little bit different. I would have came in and said, you know, X670E is going to be targeted toward a prosumer crowd. Is going to be someone who needs storage, someone who needs connectivity, someone who actually will use USB4, someone who will actually run a RAID 0 or a RAID 1 or maybe RAID 1.0, or, you know, someone who's actually going to take advantage of these features that you typically would only find in HEDT or, you know, maybe Workstation, you know, that sort of thing. I feel like marketing this stuff for the gaming crowd was a mistake, because I feel like by doing that, they create a lot of resentment with the public in terms of everything being so expensive. Why are motherboards $700? Why do I have to spend $500 for a 7-segment debug code? Like, what, that used to be a thing on like $200 or even like $150 motherboards used to come with those. So I don't know how we went from that to where we are now, where it's like, if you want, like, I'll give you guys a really good example. The Asus ProArt Creator board is a $500 motherboard. Let's look it up. Let's look it up, because now I might go on a rant, because this is ridiculous. So let me show you guys something. This is what I'm talking about. Like, Asus X670E ProArt Creator, whatever the name is. Let's look at this. Let's look at this. So look at this. This is a $500 motherboard, and it doesn't have a debug code. Now, here's the thing. Day one, these things have long post times. Without the debug code, how are you going to know that you're memory training? You know, unless you know, okay, that little red LED is indicating that you're memory training. I don't like the Creator because it's $500 and it doesn't have a debug code. They do have the debug code on the Strix, but it's like, why couldn't they just put the debug code on this? Then this thing would be amazing. But no, they're going to say a $500 motherboard, and they're not going to give you the debug code, so you have no idea what's wrong when the thing doesn't wake from sleep. Yeah, you get 10 gig LAN, you get USB4. So yeah, so in that regard, it's like the Tai Chi, because I think the Tai Chi is the same thing, right? Like, let's look at the Tai Chi, because I think Tai Chi has 10 gig LAN. Maybe not. No, it's 2.5. Okay. So the Tai Chi doesn't have 10 gig, but it does have USB 4. And it has it's a $500 motherboard, and it has the magical little debug thing at the bottom. So it's like it trades 10 gig LAN for the debug, whereas the ProArt takes away the debug but gives you 10 gig LAN. I think so. I think the ProArt is the cheap. Well, I don't know. That's a good question. Unless there's like a B650 that has it, but I haven't looked at those yet. But this is the sort of thing, right? Like, I feel like the narrative was set wrong. Like, the reason why I think there's a lot of hesitation to jump in on this platform is because I think they should have launched B650 together with X670. They should have launched them together, because that would have given the consumers the full range from the cheapest to the most expensive. And then I think it would have gone over a lot better with the public. Because honestly, these X670 boards feel more like high-end desktop, like prosumer boards. They don't feel like they're for a gamer. Like, as much as they try to dress them up with RGB and make them look like they're all gamery and stuff, it doesn't look right to me. Like the connectivity, the fact that they have all these expensive redrivers, they have like Intel controllers for USB4, they have, you know, a lot of this like high-speed like 20 gig USB and all this stuff. Like that's stuff that most, like if someone's building this to play Fortnite, this is complete overkill and doesn't really make any sense at all. Like a typical gaming PC should really consist of either the 7600X or the 7700X, and it should have a B650 motherboard. And hopefully there are B650 boards that actually have debug codes, and I think there are. I think I looked at like the AORUS Master, the X6. Let's replace this one. Now let's start looking at the B650E AORUS Master. Let's see if this one has it. Yeah, so you're going to be able to get B650 boards that have postcode debug displays on them. So that's nice. That's very reassuring, because I just know that from last year when I built my Alder Lake system, I bought a DDR4 motherboard, and no DDR4 motherboard for Intel 12th Gen has a debug code. Not a single one. And none of them support SLI. Like, the only motherboard that supports SLI, I think the Maximus Extreme, and then the only other one is like the MSI Unify X, but those are expensive. So it's pretty ridiculous. X670, no, why do I say X670? Z690 for Alder Lake is where well, I'll take that back. Motherboards started getting really expensive last gen AMD. So X570 was when motherboards started getting expensive. It was when they first introduced PCI 4.0. Problem is prices. I haven't built a low-end PC in a long time. But these prices certainly won't be high-end. But see, the thing is, my opinion on this is, when I look at B650E, this looks equivalent to Intel's Z series. This AORUS Master that we're looking at, this is the B650E. B650E looks very, very similar to what you get on the Intel Z690, because they both give you PCI Gen 5 on the graphics card slot, but actually this is better because I believe this gives you... Do I have it open? This is the master. No, I don't. I closed it. Let me open it again. This is the... Why do I have this open twice? No, this is okay, let's look at this. Let's study this. We'll probably go look at an Intel board too here, just to compare, just to prove a point here. But so this is what's coming out. I think you'll be able to buy these next week. But I'm telling you, like, if you want to avoid a lot of headaches, I have a feeling that the B650 motherboards are going to post a lot faster than the X670. And the reason why is right here. Because it only has one chipset, just like the Intel motherboards, and just like every single previous gen Ryzen motherboard. So you get one okay, and by the way, for those that don't know, X670 is literally two B650 chipsets. This is a B650 chipset, but if we look at an X670 motherboard, this chipset in the middle is actually a B650 chipset, and this one is another B650 chipset. So basically, if you want to compute it logically in your head, X670 equals 2X B650s. It's basically two B650 chipsets. There's actually no such thing as an X670 chipset. It's literally two B650 chipsets that are just daisy-chained together. The non-E X670 only has one chipset. Yes. No, that's wrong. All X670 is two B650 chipsets. I can show you guys one that I was looking at earlier. So the X670 non-E AORUS Elite AX. So this is a non-E. This is a regular X670. Now let's look at the block diagram. Because what you'll see is that this still has two B650 chipsets. The only difference is you get, wait, what? Okay, yeah, here's what's different. So if the E is not at the end of the name, so if it's X670, the graphics card, so the bus from the CPU to the expansion slots is only Gen 4. That's the only thing that's different. You still get a PCIe 5 bus, but that only goes to a single M.2 card or M.2 drive. That's the only difference. The lane allocation underneath for the primary and secondary chipset is exactly the same as X670E. There is absolutely no difference. You still get 12 lanes of Gen 4 per chipset and 4 lanes of Gen 3, plus all the random USB. So that's what I'm saying. Like, the way to know this is to read the Tech Power Up article. This Tech Power Up article, let's zoom in here. So it was posted May 31st of this year by the Lost Swede. Yeah, this has been out for several months, and this shows all the secrets. This shows you what AM5 has the interfaces on the CPU. It shows you how many displays you could potentially do. 4 display outs off of the CPU. You can run 4 monitors off of the CPU. In fact, you might actually be able to run more than that, because technically 0, 1, and 2 off of the 3.2 Gen 2 on the CPU supports DisplayPort Alt mode. So you could technically, in theory, assuming there's no limitation on resources, you could literally run 7 monitors off of the CPU's integrated graphics. That sounds crazy, and I don't think any motherboard is going to support that. But from looking at this, the CPU itself, the socket, AM5, has pins. Out of that 1,718 pins, that pinout array allows for this sort of connectivity. So if we're talking X670 non-E, the only difference is, if you look at this lane allocation, lane 0 through 19 are only running at Gen 4 speed. Lane 20 through 24, or lane 20 through 23, will still run at Gen 5. That is the only difference between X670 and X670E. X670 is still going to consist of 2 B650 chipsets, and the chipset is wired like this. So this is a B650 chipset. So every single B650 motherboard will support this kind of connectivity. And every X670 or X670E motherboard, doesn't matter which one, both of them have 2 of this chipset. So there's a primary one which has access to all of these lanes and all these USB ports, and then a second one that has the exact same lanes and USB ports. So that is the reason why I feel like the X670 platform in general feels more like a Threadripper or like a traditional old school Intel HEDT, you know, like a Skylake X or X299. That is the reason why it feels like that. Because think about it, you're getting 2 arrays of like all this connectivity on every X670 motherboard, right? And if you step down to B650, you get 1 of these, but you still, you know, that's still a lot, right? Like, you still get, what is this, 6 USB 2.0, you know, 6 USB 3.2 Gen 2, and then you can always run like a 20 gig USB. So pretty much every B650 motherboard is probably going to come with at least one 20 gigabit USB Type-C on the back. And then you've got your Gen 3, which can also be SATA. So every single B650 motherboard will have at least 4 SATA. You can get more if a motherboard manufacturer throws an ASMedia controller off of lane 4, 5, 6, or 7. They can drive 2 SATA drives off of 1 lane. I mean, there's a little bit of bottlenecking going on there, but the controller, the ASMedia controller, the idea behind doing that is the ASMedia controller implements something called flow control, so it kind of tries to mitigate the bottleneck that could happen, rather than just running like a hub or something. I mean, having collisions with the data, which for read and writes is not a good thing. So that's how they can extend that with ASMedia controllers. So you can see like all your like Wi-Fi 6E, your 2.5 gig, all that stuff's going to be taking one of these lanes. And then remember, storage is really what eats up the lanes really quick, because every M.2 drive requires 4 lanes of Gen 4 or Gen 3, depending on what it is. But in this case, they're always going to be Gen 4 because they want to give you SATA backwards compatibility, and SATA and the Wi-Fi and the LAN is going to eat up the Gen 3 lanes. So pretty much all your storage is going to go onto the Gen 4 lanes. And there might be some resource sharing with like an X4 expansion slot at the bottom. So this is literally the best article on the internet for anybody who's trying to figure out like lane allocations. And the funny thing is, it's been around since like May, or like very end of May of this year. It's been sitting out there, ignored the whole time. But if we look at Alder Lake, right? So here's Alder Lake. This looks a lot like the B650 chipset, right? Because you got a single chipset. You have your 4 lanes. It's 8 lanes of DMI 4.0. But essentially it's the same thing as PCI Gen 5 4. So you have 12 PCI 4, 16 PCI 3. So the difference here is you get more Gen 3. So the benefits of doing it that way is that you can run more random peripherals off of the Gen 3 without having to like run an ASMedia controller. So Intel does it differently. The negative of going with the Intel solution is that you don't get any Gen 5. So, you know, your super fast RAID SSDs or whatever you want to do with like multiple M.2s, you're not really going to get that with the Intel platform. You will get up to 4 drives, but that's going to eat up the PCI Gen 4 lanes really quick, just like on the AMD stuff. So in terms of feature parity, they're pretty much comparable, right? Like the lane allocation. The way I see it, it's like the Z690 gives you a little bit more because it has more PCI 3 when you compare it with a B650 motherboard. But as soon as you try to compare this with a X670 motherboard, this thing looks like it has a lot less because it doesn't have any Gen 5 besides the PCIe slot, the single 16 slot. So it's somewhere in the middle. It's closer to like a B650, but it's interesting. But yeah, I think for the average user, you know, like a single one of these is enough. Like SATA, honestly, SATA is kind of slowly being phased out. So I think like PCI connectivity, M.2s, that's going to kind of be where things are going. Flash memory is where it's at. So I think like 4 SATA, guaranteed 4 SATA minimum is okay. I think most of them are going to be 6 because they're gonna hang like an ASMedia controller off of one of these and give you 2 drives for one. I think that's going to be very, very common. I mean, I've seen that on like almost every single X670 board I've looked at. But yeah, it's all about use case. It's all about lane allocation. And never did I think that I'd be able to make recommendations of certain motherboard brands based off of use case. It used to be you didn't really think about it that much. You just kind of chose whichever brand you favored one over the other, or you know, all of them had like 8 SATA drive ports. All of them had a bunch of USB 3, you know, 5 gigabit USB 3 and that kind of thing. And now it's like, oh no, we got USB 4 on some of them. We have a lot of PCIe connectivity for some of them. Some of them give you a lot of storage, like pure storage, no sharing. And then you have like the jack of all trades, master of none kind of motherboard, like the Asus Crosshair Extreme, which gives you a whole bunch of options, but you know, there's potential asterisks next to a bunch of them, depending on what you're doing. So yeah, so So like I was saying earlier, I guess just to kind of close things out, X670 doesn't really feel like it's meant for a typical gaming rig. It's almost like a prosumer workstation. And B650 I think is going to be where the gaming PC is going to be at. It feels like they're giving you a lot for just the single B650 chipset. You're getting the Gen 5. You're still getting the 24 Gen 5 lanes. So as long as you're on the E. If you're on the non-E, then they downgrade the X16 to Gen 4, but you're still getting the M.2. So let me see. What was the only other thing I wanted to look at here? Yeah, so I just want to take one more look at... This is the AORUS Master B650E. So yeah, see, you're still getting the Gen 5 bus. So all your graphics, 2 of your M.2s are all Gen 5. And this is a B650 board, which is supposed to be a more budget-oriented board. And you can see why it's going to cost less, right? It's half the chipset count. So there's no secondary chipset. So that's definitely going to be cheaper. It's going to be more in line with what we're used to. And with DDR5 continuing to go down in price over time, I think, like, in terms of affordability, you know, give this like 4 to 6 months. These, like, right around whenever the X3D CPUs roll out, I feel like that's when a lot of people are probably going to jump on the Ryzen bandwagon. Is because, first of all, they'll help fix a lot of the UEFI issues that we're running into right now. Those X3D CPUs are probably going to be super good at gaming. And, you know, B650 will be a little bit more mature. And DDR5 will also be cheaper, hopefully, unless there's some disaster happens and DDR5, like, goes back up in price. But hopefully that doesn't happen, but who knows. We live in some strange times these last couple of years. But interesting stuff indeed. Like, very, very cool. So the only other thing, I guess we're kind of done talking about the motherboards and the chipset. I think hopefully this video or this stream answers a lot of questions people had about the platform in general, because I know it's very, very confusing. Astrophotography micro to ITX build from the X. You mean X670 or do you mean B650? You said X650S. Are you talking about X? Not sure what chipset that or what platform that is. So there are some ITX platforms. The other thing too is Asus is the only one that has ITX and micro ATX on the X670. But MSI did show off. MSI did show off B650 ITX and mATX. The current motherboard on AM5. You mean ITX? So let's look up the gene. I think it's ATX though. Oh, this is mATX. Yeah, so I thought there was one. I thought there was an ITX board. I don't know if it's if it was someone, it had to be Asus. Micro ATX. Oh, ITX. Oh, the Strix. Here we go. So they do have one. They have the Strix. It's an ITX. I don't know why they keep doing this. Okay, so the ROG Strix gaming Wi-Fi. So this, the problem is it's Asus, which means we probably don't have access to the block diagram. But just by looking at this, where does the... Actually, let's look at the tech specs real quick. So I haven't really paid much attention to the mATX and ITX boards. Let's see. So I don't really know. Okay, so you get USB4. You get USB4, which means they have a probably an Intel controller on there, because I don't think so here it is. The JHL 8540 USB4. So this is PCI Gen 3, 4 lanes. I guess there could be a way to wire it to PCI 4, 2 lanes, but I've never heard of anybody doing that. But they might do that. Who knows? And then you get 5. I mean, it looks like you get a lot of connectivity. I mean, you still get the full double chipset. Because it's ITX, it's going to be dual chipset. Even though it's so small. So this will be a really interesting one to see how they actually constructed it. Because it's so small, they have to make space for the VRM. And the thing is, I don't really know where they're going to run the second chipset on this. Unless they have it on the back, which I don't think they're doing. So Intel 2.5, Wi-Fi. So this is 1 lane. That's 1 lane. This is taking up 4 lanes of Gen 3. So, which means, okay, what this tells me is that the primary chipset, all 4 of its lanes. So if we go back here to this diagram, although they could be running it off of the CPU. Yeah, they could be running this Thunderbolt controller off of the CPU. Without the block diagram, I can only guess, unfortunately. I don't see... Well, what? Okay, you know what? I just thought of something. Where's the storage? So it supports 2 M.2 slots and 2 SATA. Okay, so that the fact that there's only 2 SATA, that frees up 2 PCI Gen 3 lanes. You get 1 Gen 5, so that's gonna be okay. That's 1. You have the full 16 for the graphics. This one goes with the chipset, so that means the second one is Gen 4. So that's using up the 4 lanes off of the primary chipset. So you still have 4 Gen 5 lanes, which the Intel controller can connect directly to. So they're probably doing it the way ASRock is doing it. So let's look at the Tai Chi. I think the Tai Chi will show us what this is doing. So the Tai Chi has, here we go. So in the case of the ITX Strix, you have a Gen 5 X16, so that's full X16 of the graphics, Gen 5, and there's no second one because it's such a small motherboard, which means you don't have to worry about, there's no PCI switch, there's no redriver, it's just straight up 16 lanes of Gen 5. That means you still have 8 more lanes. So they give you 4 of those lanes goes to the M.2, that's Gen 5. So now you have 4 lanes left. My guess is that they're doing what the Tai Chi from ASRock is doing. They're taking the last 4 lanes and they're wiring that up to the Intel USB4 controller, the Maple Ridge. So this is that this thing, the JHL 8540 USB4. So that's giving you 2 40 gig Type-C ports off of the Gen 5. So I'm pretty sure that's how they're doing it. And then they're giving you a bunch of the USB. All this USB stuff, I don't really care to look at because this is derived from either the CPU ones right here or they're off of the chipset ones. And remember, there's 2 chipsets, so there's actually this twice. So that's why USB just kind of fits however you want to fill that out. And then audio, that's going to be off of USB 2 on the CPU. Could be chips, it doesn't really matter. And then your Wi-Fi. Okay, so when we get down to the Wi-Fi, this is running off of PCI Gen 3. This is 1 lane. The 2.5 gig NIC is also PCI 3.0 1 lane. So these are two lanes gone. You have 2 SATA drives. That's 1 lane per SATA drive. It says it right here. So that's 4 lanes of PCI 3. So the 2 SATA and the Wi-Fi and the 2.5 are all using up this orange section here. off of one of the two chipsets, either the primary or the secondary. Doesn't really, I mean, it could be either one, like which means you still have four more, right? So that means they could give you more. Now I'm just trying to look through here to see what they could actually connect to that. I'm surprised there's only 2 SATA ports, because I feel like there's extra capacity with that second chipset to give you more SATA ports. Because it's not like they're giving you like add-in cards or anything. It's such a small motherboard. So all I know is it's almost like this could have been a B650 motherboard. Yeah, but for some reason there's 2 of them on there. I don't really know what they need the second one for. Looking at this, yeah, there just doesn't seem like there's a lot of stuff connected here. So I don't know. I don't know how they're using the second chipset. I don't really know. It's almost like it's a single B650 chipset. I don't really know what that second one's doing. Right? Because you only have 2 M.2s. One of them is Gen 5. The other one's off the primary chipset. You don't have any, as far as I know, let's look at the gallery. So this thing, there's no DIMM.2 slot, right? Like, that's some other thing. There's USB4. Wait, no. Yeah, there's one. Yeah. So these 2 USB-Cs are the 40 gig. These are the ones connected to the Intel Thunderbolt. You don't even have 10 gig LAN, so I'm not even sure how they're using that second chipset. This is one of those things where I feel like they could have just made this as a B650 ITX board. And it probably would have just been fine. Like, I don't really know what they're doing with the second chipset. Unless they're just wasting money. Like, they just have the second one just there hanging out with nothing. My guess is that there's probably USB headers. But I don't really see a lot of USB on the back. They have active cooling. There's a fan right there. 1, 2, 3. Yeah, I don't really know what they're doing. I'm surprised. This looks like a B650 board. This doesn't look like an X670 board. Now, I know that MSI is going to release an ITX B650 board, which let me see, MSI B650 ITX. Takeover. I don't know. I know they have it though, because I saw the presentation. I saw the main product marketing manager present these boards. I think it was either 2 days ago or yesterday. So I know MSI will have an ITX, and I think they also have an mATX. But they're both B650. But the thing is, when I look at that ASUS board, honestly, X670 doesn't make any sense for this. Like, I can't figure out what they're using the second chipset for. It's almost like, I don't want to say that they're wasting money or they're like scamming customers by charging them for an X670, but they're only selling them like a B650. But, oh wait, is this like a... So there's the SATA. No, there's the SATA. But there's no SATA like on the actual PCB. So it's like... What are they doing? There's like... The M.2s go here, there's 2 of them. I don't know. This looks weird. Like... This looks like it should be a B650 board. Maybe this is why they don't publish their block diagram, because maybe it would show like their smaller boards are a scam. I'm not trying to say that's a scam. I just don't know what they're connecting the second chipset to. But they're definitely charging you for a second chipset because the Gene board is very expensive. This is like a $600 motherboard. But yeah, I don't know what they, cause let's go back to this, right? Like they gave you the display out. They're using Thunderbolt to do display out. So that's off of a controller which is using PCI 5.0 lanes. So this layout makes sense. From the CPU, it makes sense. What doesn't make sense is this. Because they give you one M.2, so that's going to take up lanes 0 through 4, and that's a 4.0 second M.2, because the first M.2 is up here on lane 16 through 19, or lane 20 through 23. So here's the way they have it laid out. So your GPU goes here where it always goes. They give you one M.2, that's Gen 5. That's going to be 16 through 19 on that Gene board. Then they give you a USB4, which I think they have the Intel controller wired up to lanes 20 through 23. So that fills in the whole CPU lanes, right? So that makes sense. They have a display out. That makes sense. There's two of them. Then there's onboard audio. That's going to be your USB 2.0 port. So that makes sense as well. So then you have, you know, potentially up to four 10 gig USB ports. Those could be Type A or Type C. Most of them probably going to be Type C. But in this case, let's look at the Type A. And they could also give you headers for these on the board. But, you know, like, I didn't really see there's a lot of space for those. They have a daughter board. I think that's going to go to the chipset, though. So now we go down to the chipset. Well, what's on the chipset? They give you a second M.2, which is Gen 4. That's going to be lanes 0 through 3. So that takes care of this. They give you two SATA ports. That takes up lane 4 and lane 5. They give you Wi-Fi 6. That takes up lane 6. They give you a 2.5 Intel NIC. That takes up lane 7. So now we still have 4 lanes of Gen 4 which connect to the second chipset, because these go up to the CPU. So you can't use these 4 yellow ones. 8 through 11 connect to the second chipset. But you still have all this USB 2 potentially, and you still have, you know, more USB. One of them could be a 20 gig port. So that's your primary chipset. Now on the second chipset, here's the problem. Now we're at the second chipset, which is basically this whole thing copy and pasted. But what do we connect here? That's what I don't know. It's not clear to me what actually connects down here, because lane 12 through 15 connect to the primary chipset. So you still have lane 0 through 11, which as far as I can tell, I don't know what those connect to. I don't see any peripheral. I don't see any add-in card thing. Like, basically, is this a scam? Is this a scam? Like, I don't know what they're doing with the second chipset, but I hope that makes sense, because if they're branding this thing as X670, that means that it has to have 2 of these B650 chipsets. They can't sell something with X670 on the name and only give you 1 chipset, because then that means it's a B650 motherboard. And if that's the case, that's false advertising, and that could be grounds for, you know, a class action lawsuit or something against Asus. But the only way that we'd find that out is we have to disassemble. Someone has to buy the board and take the heat sinks off and look at it, you know, look at a bare motherboard to see if those 2 chipsets are actually there. But because this came up in the MSI Insider. Somebody asked, it was asked on their stream for MSI multiple times. They asked MSI, will you have an ITX or an mATX, MEG or MPG X670 motherboard, because Asus is offering the Gene, right? Well, at the time, they said that they can't comment on future products. But yesterday, in the AMD Meet the Experts session, they did say, they showed off their B650 boards, and lo and behold, they had ITX and mATX B650 boards from MSI. And when he answered the question this time, he said that MSI decided to go with B650 for small form factor because they didn't see the value in an X670 motherboard for small form factor because, you know, it's so small. What are you going to connect there? You know, basically they're running into the problem that Asus is running into if they were to give you an X670 board. They do use that dock on the other picture. Do you think the second? Well, what does the dock do? Okay, what does the dock do? This is just USB. It's got a USB. It's got a 10 gig USB. Like, what does this actually do? Okay, you have a DAC. That could just be like onboard audio. Like, I don't know what because look, this is just USB. USB, there's so much USB on the first chipset and the CPU and the second chipset. So I don't know. I don't know, man. I don't know what they have. It's like lane 0 through 11 on the second chipset are completely empty and unallocated, which is such a waste of resources. So that's really, really weird. That's just USB. I mean, you could easily fit that on a B650 board. So it looks like, okay, there's your two SATA. So that's 2 lanes of Gen 3. And you've got more USB. And this looks like USB 3. And there's 2 of those. So that's fine. That's going to give you a bunch of 5 gig USB, potentially 10 gig on there. I don't really see it. I don't know what... I mean, are there Thunderbolt headers? Are there multiple Thunderbolt controllers on here that they wired up there? I don't know. That's a mystery to me. Only 2 M.2s. And no further expansion slots for PCIe because it's too small. Really, really weird. I might have to look for, like, find somebody who has this board that actually, like a reviewer or someone who disassembled it, just to see what's actually under there, because that's a really interesting mystery. That's even more, now, this board is now even more of a mystery to me than the Extreme. Because I think I figured out the Extreme. I've solved the puzzle, but this one's still a Rubik's Cube. But I'm glad you brought this one to my attention, because I had no idea that this thing would be so confusing to figure out. But let's try to find, I think MSI has a MSI MPG B650E Carbon Wi-Fi. Here we go. No, that's not it. Wait. Oh, that is one of them. But I'm trying to find the small one. Yeah, that's a standard B650 board. Hold on, maybe it's on the product page. MPG B650 or no? Yeah, B650. Oh, there it is. Check this out. There it is. Okay, this is a is this yeah, this is ITX. So B650i, I don't understand why it's I guess ITX. But let's look at this one because hopefully they have a block diagram. Oh, they don't have it up yet. We can't look at it. They haven't updated the manual, or they haven't posted the full manual yet. They only have this, so we can't see it. That's unfortunate. But the thing is, let's just read, like, see what it actually. Wait, where is it? Did I close it out by mistake? I have way too many of these tabs open. Let me see what it's got. So this we know is only one chipset. So let's see if this actually fits everything. So, okay, we've got, you know, the full Gen... That's Gen 4. Okay, this is not a B650E. This is a B650, like, non-E. Which means this is not going to have Gen 5 to the graphics card. That's all that means. So you still have... where is it? Storage. You have 2 M.2. Oh, you know what? This actually looks like it doesn't have Gen 5 at all. This is all Gen 4. So both of them are Gen 4. One of them is from the CPU. which means they still have 4 lanes for the CPU, or from the CPU. So you have 1 to the chipset. Okay, that takes up your 4 of those lanes. You still have 4 more because it's a B650. There's no second chipset. So if we were to map this out, they give you 2 M.2s. So we go over here. The first M.2 is here. You still have this free. So we don't know what they're connecting on 20 through 23. The second M.2 is 0 through 3 on the chipset. For SATA. So the 4 SATA is going to eat up every single one, unless they're doing it as media controller, which I don't think they're doing that. So all 4 SATA is going to eat up all PCI Gen 3. So there's no more Gen 3. They're all gone. All to storage. RAID 0, 1. Okay, the fact that all of them support RAID 0, RAID 1, and RAID 10 for SATA, that means that there's no as media controller, which means that every single one of these orange lanes, 4, 5, 6, and 7, each one of them is mapped to a single drive. So 4 SATA drives, 4 lanes. And they all support RAID. Alright, you got USB 2, that's going to be chipset, because the onboard audio is going to use USB 2 off the CPU. So you got 2 off the chipset, so that's going to take 2 of these gray ones, so 16 and 17. 2 USB Gen 1 Type A on the back. That's Gen 1, that's 2 of them. That could be off of the CPU. So that's probably 2 and 3 off of this. But it could be from this, but I think it's from the CPU. And I'll explain why in a little bit. So 3.2 Gen 1. So this is this could also be from the CPU. Actually, no. These are off of the chipset. These are off of the CPU, and they're on the rear. This one is a Type C. That could also be from the CPU. This is from the chipset. So, like I was saying earlier, the 20 gig is almost always from the chipset, because if we go back here, it says it highlights lane 22 and 23 off of the B650 chipset. It highlights them in red, and it shows Gen 2 by 2, and it says down here, the first 2 USB 3.2 Gen 2 lanes can be combined for a single USB Gen 3.2 2x2 20 gig. So 22 and 23 together, fuse together, and make one USB 20 gig port. So that's that 20 gig port. So it's off the chipset. Why do I keep opening the wrong tab? This one. So that's this one off the chipset. All right. So for the LAN, Realtek 2.5, because all the SATA has taken all the Gen 3 bandwidth, this has to go to the PCI Gen 4. So this is taking up 1 lane of Gen 4. AMD Wi-Fi 6E. This is actually AMD Wi-Fi. This is not Intel Wi-Fi. This is not Realtek Wi-Fi. This is AMD Wi-Fi. So AMD teamed up with MediaTek. This is another thing that I found interesting about the Ace, because the Ace does have AMD Wi-Fi 6E. So does the Godlike. So this is actual AMD, for the first time, Wi-Fi 6E. They teamed up with MediaTek to create their own wireless network interface card. And this also, I believe, supports Bluetooth. Yeah, so Bluetooth 5.2. This is going to take up 1 lane of what should have been Gen 3, but in this case, it's going to be Gen 4. So this and this are going to be on lane 8 and 9. Okay. So moving on. Realtek is on the CPU. That's a USB 2.0. And I think that's it. You have, let's see. I don't see any Thunderbolt header. I don't see any USB4. So that's basically it. So they're definitely using up almost everything. The only thing that looks like is being wasted is these lane 10 and 11. Are the only things that are unwired. Unless there's some kind of header or something on the board. But yeah, it looks like in terms of optimal resource usage, MSI is doing it really, really well. Like, they're using up almost all the USB ports, and they're using up almost all the PCIe 4.0, and they're not wasting anything. There's, like I said earlier, there's only like 2 lanes. 10 and 11 are basically not connected to anything. But yeah, that's a pretty solid choice. I mean, you can see the I/O. It looks like there's not a lot of USB on the back, and that's probably because they have a lot of headers that go to the front. See, front. Yeah, so not bad. If I was gonna go small form factor, I mean, I think this is probably gonna be a way more affordable choice. The Gene is like $600. Definitely not worth it, considering what we looked at. That second chipset is a complete waste of money. They're not really using it at all. So unless there's some way to like solder a Raspberry Pi to it or something, I don't know. This would be the one to get if you wanted to go small form factor. Or this is what I would recommend. It's more balanced. It has pretty much everything you need. And it makes sense. Like the lane allocation, the resource usage makes sense to me. The Gene does not make sense to me. So it seems kind of fishy. Like that Asus, this Asus board looks really, really sketch. This is strange. And I think they have another one. I think MSI did hint at an mATX board, but I don't remember what it was called. I can't remember if it was an MPG or if it was like a creator board, because they did say they have their creator line. Basically, MSI is there's creator, there's something below MPG, then MPG is kind of in the middle. And then there's MEG. MEG is basically the equivalent of Crosshair. MPG is more like Strix. And then whatever was, I think MAG, MAG, or something, some other MSI acronym was basically like Asus Tough or Prime. In terms of product segmentation. But yeah, so they've got one. If I was going to build a small form factor, I would definitely probably go B650 anyway. Because like I was saying, you know, like X670 doesn't make any sense. Think of it this way. Like I was saying earlier, X670 is kind of like Threadripper. It's like Threadripper Lite. It doesn't make sense to make a small form factor for something like Threadripper. So yeah, I understand why MSI didn't create any, why they decided not to build any X670 small form factor motherboards. It's because it doesn't make sense. Like, there's not enough space physically to actually fill up that second chipset. Yeah, once this stream is over, what I'll probably do is I'll try to go through it, and I'll try to chop it up into like sections on what we talked about. So there'll be a section on the block diagram. There'll be a section on what we're talking about now with like small form factor. Small form factor analysis is always kind of interesting because it raises a lot of eyebrows with how the manufacturer, like you're adding additional constraints on what a manufacturer can do because of the dimensions. And I always find that kind of interesting. Like they have to work within a certain amount of space, and they want to try to like pack as many features as they can. So, you know, that's why they end up with active cooling and stuff like that. But it's pretty cool. So, I guess moving on now, is anybody planning to get Intel Arc next week or RTX 4090? Let's look at this real quick. So wait, why is this? Oh, they actually reviewed the Valkyrie. That was today. Oh, Tech Power put up a review on the BIOSTAR Valkyrie. I was actually really interested in this motherboard. So this motherboard, I knew about this board since like early August was when this was first announced. And I was hoping that this would probably be like the most affordable motherboard. So if they actually show the price info on here, that would be really good to know. Let's see. Retail price. BIOSTAR has not provided a suggested retail price. Ideally, this motherboard should be in the $400 to $500 range. $400 being a solid contender among all X670E. $500 reaching into look around first before you buy. So this one looks pretty solid though. Like it looks a lot like when I look at this motherboard, this looks like the Ace if it was ATX form factor instead of eATX form factor. Because, you know, you still have the full metal, reinforced X16 slots, and you've got the you got the SATA, you got basically all the same kind of things. It really kind of depends on how they've allocated the resources. And look, 1, 2, 3, 4, you still get the 4 M.2s. In fact, it looks like they've got something else going on here. There's like an extra one over here. Looks like 1, 2, 3, 4, and then is this a fifth one? Huh. Oh, okay. That's they have a removable Wi-Fi card. That's interesting. I don't know if that's a good thing or a bad thing. BIOSTAR has an M2 key, E prepped for a Wi-Fi card, but doesn't it already come with Wi-Fi? I thought it has Wi-Fi. It has it right there. Like that's unless that's only where the antennas go. That's strange. It does have the back plate. I mean, that's more than like the Carbon from MSI, which is like a $479 board. So yeah, when I first saw this, I was thinking, you know, this is probably gonna be really good value. You got reset, you got power, you have the debug. You pretty much have like everything that you would expect. You have clear CMOS button. You have an LN2 switch. What is this? This is supposed to be a BIOS switch. Oh, a BIOS switch. Oh, you got dual BIOS. You got dual BIOS on a motherboard that's supposed to be somewhere between $400 and $500. So, I mean, the only one that has dual that I know of, I know the Extreme from Asus has two, but that's a $1,000 board. Dual 8-pin for the CPU. It looks like it's got the reinforced this. You have the CPU optional fan 1. So that's really good. It looks like you've got the addressable RGB and the newer one. And there you go. There's your two chipsets. You got your primary and your secondary. So that's really good. See, this board looks good. If this was at Micro Center on launch day, I probably would have gotten this. If it was like $50 less than the AORUS Master, I probably would have definitely gone with this. 2.5, lots of USB-A, which realistically most people who use a desktop PC as opposed to people who use like a laptop are probably going to benefit more from USB-A 10 gig as opposed to the like taking away a USB-A to give you another USB-C. So it kind of depends. This doesn't look like there's any Thunderbolt from what I can tell. And that's why I was saying earlier, like this board to me looks a lot like the Ace from MSI, except this is an ATX, standard ATX board instead of an eATX board. So in terms of case compatibility, this one's better. So yeah, I mean, this seems to check all the right boxes. It doesn't have USB4, but you know, like not that many people actually need USB4. So you got 4 M.2. What I want to know is how many of them are like Gen 5? The Master and the Gigabyte Extreme didn't have dual BIOS. Oh, the Ace has dual? That's nice to know. That's nice to know the Ace has dual. Yeah, this is. So it looks like. Okay, the motherboard. Wait. Here, BIOSTAR has implemented 2 Gen 5 M.2s. Okay, so they're doing exactly what Gigabyte is doing. Except I wonder how this is allocated. That means that means so these two are your typical, this is 16, and as soon as you plug something in over here, this drops down to 8, and this can go up to 8. So literally, you could take the MSI expander card and plug it in over here, and it would work. Just like it does in the Ace. And then this bottom slot is probably a by 4, because if 2 of the M.2s are Gen 5, that means 1 M.2 is Gen 4, and it goes to the primary chipset, and then the secondary chipset has the 4th M.2, and also it has this expansion slot. Or what BIOSTAR could do is they could take the by 4 expansion slot, connect that to the primary chipset on lane. Oh, I don't have the article up anymore, but you guys know what I'm saying from that diagram. This would be lane 0 through 3 on the primary, and then the 2 M.2 drives that are Gen 4 would be lane 0 through 3 on the second chipset, and 8 through 11 on the second chipset. So that's probably how they're doing it. And then your wireless, that's going to be Gen 3 1 lane. Your 2.5, that's Gen 3 1 lane. You got 4 SATA on the bottom chipset. Your connectivity, your network stuff is going to be the Gen 3 in the middle, in the primary chipset. So yeah, this is a pretty solid board. Very, very easy to understand. Very easy to understand. There's no weird Thunderbolt controllers to account for. So very straightforward. This is a really nice board, actually. Debug, postcode. You know, there's really nothing wrong that I can fault on it. I mean, it being BIOSTAR, you know, I've never used BIOSTAR before. But they're, you know, it's another Taiwanese manufacturing company, just like all the others, like Asus, Gigabyte, MSI, and ASRock. So they're just less well known outside of Asia. But it'll be cool if they have this. You know, this is actually a pretty solid choice. They're probably going to be pretty price competitive with this board too. Like this would probably price right around. I would guess this is going to go for about the same amount of money as an MPG Carbon Wi-Fi. But I think this is probably better than the Carbon Wi-Fi, because the way they've allocated the slots and stuff, I think, is a little bit more optimal. And I think this board, unlike the Carbon, this one has so many buttons, physical buttons on the thing. You got the clear CMOS, you have the power reset, LN2 mode, BIOS switch. I think the Carbon Wi-Fi doesn't have the dual BIOS. This has a dual BIOS, so that's very nice. So really cool. It's just not, they're just underrepresented in North America, that's all. But I think this is pretty solid. Actually, let me go to the conclusion. Well, let's just look at the benchmark real quick. Let's see. So higher latency than Taichi and Master. But, you know, that's like 3 nanoseconds. Who cares? Read, the memory performance is a little bit worse. But again, we're talking, you know, that's like what, 1,000 megabyte per second difference. Memory writes, memory copies. So it's probably Cinebench, basically margin of error. Yeah, so Blender again, it's almost the same. Like PC Mark, it actually outdoes the other two. SuperPi, it's faster than the Taichi. So, you know, it's a motherboard. It's kind of the same performance. Gaming. Okay, so here's where it's a little bit different. So what I wonder is if this is just a matter of the Valkyrie board selecting lower or higher latency RAM subtimings when it does memory training. One thing that'll be interesting to know in the review is how fast is this post? That's what I want to know. Or how fast does it memory train? Because if it's one of those deals where it trains faster, but it's probably going to use looser timings. Let's see, what did it say? So the pros, Gen 5, at 2M.2 Gen 5, 6 SATA, robust VRM, 105. So basically it has the exact same power stages that the AORUS Master has. Postcode, dual BIOS. That's better than AORUS because AORUS doesn't have that for some weird reason. Third PCIe slot. That's what the Ace has. That's what I like about it. 5-jack audio. Oh, 5-jack audio. Again, AORUS gimps you on the audio. And then BIOS easy mode. So everyone has that long boot time, but I think Tech Power Up dinged everybody on this. BIOS lacking extra OC features. So okay, that could be a deal breaker for enthusiasts that actually wants to use curve optimizer and stuff like that. Weak memory support. That's not good. This right here explains why it didn't perform as good as the Master and the Taichi. Because it's probably negotiating looser timings when it does memory training. So it would require more tweaking. And the fact that it lacks like memory profiles built in, the way the ASUS Crosshair boards have that. I mean, that's kind of where... so now we know why it's cheaper. It doesn't give you as many features that you'll actually use. No 10 gig, but you know, it's probably not going to be that expensive. No USB4, I don't really care. And no Wi-Fi. Okay, so it actually doesn't have Wi-Fi. That's interesting. So it has... Okay, so basically, why doesn't... Okay, so it has the antennas. That's really weird. That is kind of janky. So it pre-wires the antennas, but it doesn't actually give you the Wi-Fi card. So, okay, that explains why this is here. Okay. Yeah, that makes this probably the most janky board, because it's like pretty much all the almost all the X670s that I've seen from the major manufacturers all have this. So that's strange. That's like another like $20 off, I guess. But hey, it's got a lot of buttons and stuff, so it's got... It has clear CMOS. You know what? Another disappointment about the AORUS Master. The AORUS Master doesn't have a clear CMOS button on the back, nor does it have one on the board. You have to short the two pins, like old school style. And I'm thinking, what is Gigabyte doing? If you want a clear CMOS, you have to buy the Extreme. You have to buy a $700 motherboard just to get a clear CMOS button? I don't know, man. Gigabyte's lineup is really weird. But what makes me a little bit tilted about Gigabyte is I have the X670E AORUS Master, but when I look at the B650 AORUS Master, this thing actually has the clear CMOS on the back. This has the clear CMOS on the back. Why does the B650E get the clear CMOS, but the X670E doesn't? That doesn't make any sense at all. I don't know, man. I'm just... The more I think about Gigabyte, the more I don't want to talk about this anymore. and they gimp you on the audio. Pretty much every single Gigabyte board, all the X670s, and so far, from what I can tell, all the B650s, they only have the line out, the mic, and the SPD, like the optical out. In fact, I think the AORUS Elite doesn't even have the optical out. I think it has mic, line out, and I think it has a line in, which might actually be more useful. I don't know. Like, I haven't used optical audio in so long that... I don't know what they were thinking. Somebody is there's a bean counter at Gigabyte that's trying to cut costs as much as possible, and I think it's slowly going to kill the company because their reputation, the power supply, the exploding power supplies, already kind of damaged their reputation. The graphics cards have been damaging their reputation. I don't really know what it is about their graphics cards is bad, because I've never owned a Gigabyte graphics card. I'm not selling you on Gigabyte. Poor Gigabyte. I don't know. Like, I don't know how they're determining what they need to put on their boards. Like, I think they've always done well with USB ports. That's never been their problem. Like, if I had default MSI 4 years ago, or like first gen Ryzen era, or even like Zen Plus, I would criticize MSI on skimping out on rear I/O in the form of like very few USB ports. That was my biggest criticism of MSI. But they fixed that during like X670. Like back when Zen 2 came out, they launched the X670E Creation motherboard, which was amazing. Like, that thing had the best I/O. They went from being like the worst I/O to the best I/O in one generation. Gigabyte now is the red step. You know what? It's almost like that statement is true, because Gigabyte used to be I think they used to be the second largest. It was Asus, then Gigabyte, then MSI, then ASRock. I think, I don't know if Gigabyte's still bigger than ASRock, but I know MSI has overtaken Gigabyte. Like, a couple of years ago, MSI overtook Gigabyte. As far as I know. And it definitely feels that way. And then ASRock has always been that weird one that people couldn't tell if it was like a ripoff of Asus or if it was like a sub brand of Asus, but it never was. It's always been independent. But ASRock just keeps doing their thing, like where everybody is chasing like trends, like doing this thing. You know, Asus does something that everybody wants to copy them, and then ASRock doesn't care. ASRock just does their own thing. Like they were the first ones to try to put Thunderbolt on Threadripper. They've always been kind of the one that's out there in left field, just doing their own thing, daydreaming, making their own stuff. That's how I've always seen ASRock. And ASRock's UEFI has gotten a lot better. The other thing too about ASRock is ASRock actually has always given you all the options in the UEFI. Like they've revealed every single option, even things that were supposed to be reserved for debug. They've always kind of left it all in there. And I think that's a good thing. I mean, Asus, as long as you have like an ROG board, you pretty much get all of that too. But Asus kind of hides some of that for like the mainstream boards like Prime. And then MSI, I think, has the best layout in terms of how their UEFI looks. Everything's like single line in the middle, so it's easy to see in front of you. But MSI, I think, if I had to criticize MSI, I feel like MSI, just like with how MSI used to not give you that much USB on the back, they also used to not give you that much in the UEFI. They disabled a lot of the debug, a lot of the like more advanced overclocking and voltage controls. They kept a lot of that away. I remember when Zen 1 first came out, I had an MSI X670E X-Power Gaming Titanium, and that thing, you couldn't even do offset mode overclocking with that motherboard. And also, you could never access the AMD Zen common options, where you could do P-state overclocking, which is basically what we have as known as Performance Optimizer, or PBO now, Performance Boost Overdrive. Like, they hid all of that. You could never access that in MSI's BIOS until, I think it was until the X670, they added that. So, but MSI's come a long way in terms of moving in the right direction, whereas I think Gigabyte has been moving in the wrong direction. EVGA. Well, EVGA used to make a lot more motherboards. I don't know what happened to them. Like, I know the whole thing with the graphics card issue, but they used to make a lot of AMD motherboards. In fact, my very first motherboard, very first PC that I built myself was an EVGA motherboard. It was an AMD socket 939 on an EVGA Enforce 4. Enforce was an Nvidia chipset made for AMD CPUs. And I ran that with an ATI X850 XT graphics card. So I had an ATI Radeon graphics card in an EVGA AMD motherboard using an Nvidia Enforce 4 motherboard chipset. So I basically had everything except Intel on that motherboard. Unless the networking was Intel, which no, it wasn't. It was Realtek. But yeah, it's kind of sad to see Gigabyte starting to flail around and not really know what's going on. I like the I honestly I do like the way the AORUS Master looks, at least for this generation. It looks really cool. It looks really cool. Like, it looks better in person than it looks like on this picture, because when it's turned off, you know, this is not this color. But this is a nice looking motherboard. That heatsink is ginormous. This top one here, I was afraid my Noctua NHD15 wouldn't fit, but it fits normally. So just by looking at this, I can already tell, like, if I had the Asus Crosshair, it would fit on there too. But see, Gigabyte, like, where's my clear CMOS button? And why is the Q Flash Plus some small, tiny little, almost like you have to use a ballpoint pen to press this down? Like, why isn't it the normal button? The normal one that's on, like, all the other motherboards. See, so that's kind of strange. But they do give you good I/O though. Like, Gigabyte's never had a problem with not enough USB on the back. Like, that's never been a problem for them. They've always been able to match Asus. But I don't know, the weird issues that I'm seeing with them, where, like, the PCI card doesn't wake up. Hopefully that's a Gigabyte only problem. Because if it's not, then it's definitely an AMD Agisa problem, which means that that's going to take a long time to fix. The high tensile strength CD-ROM ejection device for that button. Yeah, it's one of those, right? Like, I don't know what they were thinking. Who makes a $500 motherboard, doesn't put the clear CMOS button on the back, and then they go, nor do they include it on the board, anywhere on the board. So, meaning there's no physical button on the board to press to clear the CMOS. I have to short the two pins down here, like old school. And then they give you a BIOS flashback button that is so small and hard to press that you have to use. Oh man, I don't know. That's the one time I decided to buy Gigabyte. Well, this is not the only time I've bought Gigabyte. You know what? I think this is a sign that I need to stop buying CPUs and upgrading to platforms on launch day. Because I'll tell you guys a little bit of story. So the very first Gigabyte motherboard that I ever purchased was the Z690 for Alder Lake last November. That was the first time I bought Gigabyte. And the only reason I bought Gigabyte was because I didn't want to spend money on DDR5. So I had to get a DDR4 motherboard, and Micro Center had a ton of this motherboard in stock on launch day. It was the Z690 Gaming X DDR4. So this is my Intel 12th gen Alder Lake motherboard, and I don't like it. I mean, it has weird. It's not like it's bad. It's just cheap. This was like a $200 motherboard. But, you know, you get a bunch of random USB, you know, 2.0 at the top. Who cares? That's where I put my keyboard, my mouse, you know, basically everything. The Xbox game control. All that stuff goes right there. And then, you know, you still have the BIOS. But it's so ghetto that you don't have a flashback button. You don't have a clear CMOS button. You still have this stupid, like, mic line out. And, you know, you don't have the 5.1 audio. You still get the 2.5 gig. And here's the funny thing about this board. This is an Intel 12th gen motherboard. Get this. the 2.5 gig NIC is a Realtek. It's a Realtek NIC. It's a Realtek NIC. Where is this at? LAN. Realtek 2.5. They even went cheapo mode on the LAN on an Intel motherboard. How do I go and buy a Gigabyte motherboard for my Intel CPU that doesn't even have Intel LAN? Then I go buy a Gigabyte AMD motherboard that strips out the AMD Wi-Fi 6 and sticks Intel Wi-Fi 6 and an Intel 2.5 gig NIC on the AMD motherboard. I have more Intel chipsets on my AMD motherboard than on my Intel motherboard. I don't know how that happens. Only Gigabyte can pull that off. It's like Gigabyte's just becoming a meme. Gigabyte. Because if you look at like an MSI equivalent, they might have Realtek, but they might also have Intel on here. So it's like, I don't know what they're doing. But this thing, the other thing about this, the thing I hate about this motherboard is that every time, so when I plugged in my AverMedia capture card, the same one that doesn't wake from sleep on the AMD, the new Gigabyte AORUS Master, when I plug it into this motherboard, whenever I try to flash a firmware update, it starts to flash and then blue screens the computer. It blue screens the computer. And then when I try to come back, the capture card is dead. It reads firmware version 0000. So it killed my capture card. Like, it bricked my capture card and blue screened on me. So I didn't know. At first I thought, okay, maybe it's the E-cores and Windows 10 not getting along. So I disabled the E-cores, tried again. It still can't, it just can't flash it. It's like the card's dead. So what do? I take out I turn it off, take out the capture card, go plug it in my Threadripper X399 2950X on an MSI Threadripper motherboard. It was the MEG Creation from 2018. I go plug it into that thing. It still shows up as 0000, but it flashes it perfectly and saves the card. And basically, the card's alive and well, and it's what I'm using here. So, saved me an RMA. Thanks to Threadripper. You know, I opened a ticket with AverMedia and complained, you know, like, I think there's a problem with Z690, but I don't even know if it's Z690. I don't know if it's Intel E-cores on Windows 10, or if it's just a Gigabyte motherboard problem. So, I don't know. No debug code, no nothing. Gimped audio, no, you know, like, I don't know. Now, granted, this is a $200 motherboard, but still, $200 motherboard, you're not even going to give me a clear CMOS or a BIOS flashback button? I get that this is their lowest entry-level brand, because it's just Gigabyte Gaming X. It's not AORUS. It's not Aero. But whatever. I mean, at least it works. I'm probably, so what I'm gonna do next Wednesday, I don't know if Micro Center is gonna have the ARC A770 cards. I'm pretty sure they're gonna have the 4090, and I don't want to deal with the line of people that's gonna line up early to get that thing. So I'm probably gonna try to walk in there, like maybe in the evening or the afternoon. I just hope that no one buys ARC so that I can get one. I really want the Intel ARC A770. I just want to play around with it and see what it can do. I do think that it will get better over time, but I don't think that it's ever gonna get to the levels of a 3070. Like, if it gets, by the time, let's just put it this way, by the time the ARC A770 becomes equal to or better than a 3070 because of driver updates, it'll be completely irrelevant by that time. It's the same argument for AMD's Vega 64. Like, Vega 64 today and the RX 5700 XT. So basically, Vega 64 today has gotten better and better and better. That it actually typically beats its old rival, the GTX 1080, in most modern titles. And what's happened with the 5700 XT, it has gotten so much better that it's actually like a 1080 Ti now, or like a 2080, where it used to be like a 2070, now it's like a 2080. So that gives you an idea of how a graphics card can actually get a lot better provided the drivers improve. So when tech tubers say that, you know, AMD's drivers have gotten a lot better, you better believe them, because man, those things have gotten a lot better. Like an RX 5700 XT is equal to a 1080 Ti in most cases now. So, and it's a PCI Gen 4 graphics card, whereas the 1080 Ti is just a Gen 3 graphics card. So it's got a lot more runway in terms of forward compatibility than the 10 series. So yeah, I mean, those are the sort of things. Like the Intel Arc could potentially do the same thing. So I do want to get one just to play around with it. I'll probably throw it in this Intel system first, because I want to test the whole Intel plus Intel narrative. I'll probably do some videos on that card. I think I'm going to do an unboxing video, provided I can get one. If I can't get one, I'm not going to go out of my way to secure one of those cards, but I still do want one. It's kind of a collector. The way I see it, it's kind of a collector's item. So I do want one for multiple reasons. But one of them being I want to collect it. The other one being that, because if they do cancel ARC, at least I can say that, you know, I've got one. So, but I don't think they're going to cancel it. Intel knows that they need to have something in the GPU space. So no matter how difficult it is to stand up that whole business unit and get it off the ground and try to go to market with their go-to-market strategy, which kind of failed, and it kind of flopped big time, really, if you look at the reviews. But I still want one, and I'm kind of the target audience. Like all the review, I think Linus put it best in his conclusion, and his reviews are typically the last ones I watch for these sort of things. But I do agree with what he said. At the very end of his review, he said that the people who should buy ARC are the people who like to troubleshoot things, are okay with writing bug reports, essentially. And here I am writing bug reports, or at least reporting things to Gigabyte with the X670E issues that I'm running into. But I'll do the same thing for Intel. So I do plan to get that card. 4090, I'm just going to completely ignore that card. I don't care. And then it doesn't make any sense. I'm on a 4K monitor, so I will test Intel at 4K. That is one thing that I noticed. None of the reviewers tested at 4K. They all mostly just tested 1080 and 1440. I think there were some that showed like a couple of games at 4K. But Intel supposedly scales well with resolution. So meaning like from 1080 to 1440, you take like a 10% hit. But going to 4K, I think because it's such a much higher amount, it's probably going to drop. Is there a case that the 4090 fits in? It'll fit in mine. It'll fit in the I have a fractal torrent. I'm pretty sure it'll fit in mine. But I'm just not going to get it. I mean, there's no point. It's so expensive. And if I have to go and buy an Ace motherboard and then try to sell off my Gigabyte AORUS, you know, I'm going to be out another $700. So, yeah, I'm definitely not going to buy no 400 or 4090. No way. I do also plan to get 13th gen Intel. I do want to get the 13900K. I have the 12700K. So this motherboard that we're looking at right here, I'm going to drop in upgrade. I'm going to put a potentially 300 watt CPU in a ghetto $200 Gigabyte motherboard. So hopefully I don't run into any weird catastrophes by doing that. This has just a plain chunk of metal heatsink, which is the bad kind of heatsink. Yeah, the 4090 is really big. I mean, I'm used to big GPUs because I've had Vega 64. You know, that was really big. But you know, a lot of people don't pay attention to AMD, so they don't know when the cards are big. Like I'll show you like Sapphire Nitro Plus Vega 64. So I used to have one of these. I do have a video of this graphics card on the channel, if this will load. So right here, this is already, like, I'm used to big GPUs, because look how massive this, well, okay, this is not as thick, but this is a 3-slot GPU, and this is from 2017. So this is like first-gen Ryzen era. So I'm used to seeing big GPUs. Like, the 4090 being as big as it is doesn't really surprise me. I mean, 450 watts, it better be that big. It might not even be big enough when I saw it. Because this is 300 watts. This GPU from AMD from years ago was 300 watts. So this thing was basically like a little bit less power than a 3080. 3080 is 320. 3080 Ti is 350. 3090 is 350. 3090 Ti is also 450, just like 4090. But the thing is, I have a feeling... Wait, do you know when I think they launch this week. I think it's going to be... I think it's Monday. I think it's on the 10th. If I'm not mistaken. But... yeah, I think it's... I mean, we can look it up. B650 launch day. Oh, wait. Okay. No, it says right here. AMD B650 motherboards retail launch 10th of October. What does it say on 15th? CPUs hit retail on 15th September. That's not right. Motherboards B650. Okay, B650 on the 10th of October. So that should be Monday, but I don't know. I mean, this is an old article from WCCF Tech, so it could be wrong. So I'm not sure. Don't quote me on that, because it might be the 10th, but it also might not be the 10th. So I don't really know. But I mean, it could be this week, this coming week. So basically, everything is coming out in Q4. RTX 4090. Let's look at Nvidia's website. This thing is $1,600. This is mostly a waste of money because, like, anyone who's going to use CUDA acceleration is going to use like an RTX A series because you have the full support from Nvidia. Like if you need to open like a case for a trouble ticket, for example, you got 3060 Ti for 500. Well, that means you only paid $100 over MSRP. Because 3060 Ti is $399 MSRP. Assuming you're talking about US dollars. But see, this is the sort of thing. This card is kind of like whatever to me. I mean, it's cool, but, you know, I feel like they're obfuscating the actual performance by trying to push everything onto DLSS 3. Like, what I want to know is how does it perform without DLSS 3, because that matters more to me than with DLSS 3. Because the problem with DLSS 3, DLSS in essence is nothing more than a fancy marketing term for upscaling. It's literally upscaling. Yes, it uses algorithms like AI-based algorithms to determine the upscaling effect or how to actually render it. But at the end of the day, it's still upscaling. So it's still not the original native image. No matter how good they try to reconstruct the image, in some cases it could be better than the original. In other cases it's worse than the original. But it's not the original. At the end of the day, it's not the original image. So that's why I don't care about DLSS. Does DLSS work on... No, it doesn't. It doesn't because it's a hardware difference. It will not work on RTX 30 series. This has already been answered by many, many people. This is how Nvidia tries to get people to upgrade. They have to sell you on some kind of feature because otherwise you're not going to upgrade. They have to try to entice you to upgrade and spend money in another way. by making features exclusive. And honestly, I think AMD needs to start doing the same thing, because the problem with AMD is not the quality. Their drivers are good. Their products are good. People who think that AMD has bad drivers has no idea what they're talking about. If they were burned by AMD in the past, that's not the same AMD of today. So the problem for AMD is that they're not able to consistently convince a buyer that their product has either feature parity or better feature parity than Nvidia. And the reason why this is because every time AMD makes a feature that's supposed to compete with one of Nvidia's features, they make it available to GeForce GPUs. So, like, the best example is FSR. Another example is FreeSync. Now, Nvidia chose to adopt FreeSync after a while because they saw that most of the monitor manufacturers were just throwing FreeSync in their... they were enabling FreeSync on the display and the HDMI ports. Whereas with G-Sync, you could never do G-Sync on an HDMI port. You can only do G-Sync on DisplayPort because NVIDIA's module uses specific extensions that only talk via DisplayPort protocol. You cannot do it over HDMI. It doesn't work. Really, their drivers have always been bad. No, they're not bad. I use AMD RX 6950 XT. I don't have any of these problems people talk about. On the professional level, only on the professional level they have been consistently good. I disagree. I think it's actually the opposite, the way I see it. I think AMD is actually more competitive on the consumer side, and they're less competitive with NVIDIA in the professional side. And this goes back to what I was saying earlier. I think that AMD needs to start making their features exclusive to Radeon and not allowing them to run on GeForce. Or at least if they're going to allow it to run on GeForce, they don't need to do any sort of validation for GeForce. They just need to, like, check a box and say, yep, it works on GeForce, but they don't actually need to verify it for GeForce. They don't need to try to claim that you can take your old 1080 Ti and run FSR 2.0 on it. For creation content, they have been poor. There's issues with their drivers right now that I can't use in some of my programs. Okay, give me an example of that, though, because I like I said, I've been using Radeon. My first PC was Radeon, ATI Radeon, on an Nvidia Enforce motherboard made by EVGA. I used that GPU all throughout Vanilla WoW, all throughout Guild Wars 1, Half-Life 2, all that stuff. Never had any problems. Hardware acceleration doesn't work in Affinity Photo. Okay. Is that using something like an OpenCL rendering pipeline, or is that literally, like, what do you use for that? Has been aware of the bug. Oh, it's a bug. Okay. Yeah, I mean, that's the sort of thing, though, right? Like, yeah. For creation, they've been poor. There's... Okay. So, yeah, I mean... That's the thing. That's the thing, though, because what I've noticed is, and you do have a point, because what I've noticed is that when you report a bug to AMD, because I have found lots of bugs in the past for, like, when I say in the past, I'm talking like 2015 or older. And I've reported them, and then they'll acknowledge it, but then it could be a long time before they fix it. So what I'll also have to do is on the back end, I'll have to go to the developer of that application, whether we're talking about a game or if we're talking about an application. And I'll have to report the bug to the developer in hopes that the developer can fix it. And usually it's one of those things where they'll either, if the developer will acknowledge the issue, they can also open a ticket with AMD to work directly with AMD. And honestly, I think that's the best way to go about it, because I think you get collaboration between the application vendor and the hardware vendor, and then I think you're going to get a lot more progress more quickly. I don't know. Now, sometimes AMD will go and contact the developer for the app without you having to go out of your way to do that, but it really just kind of depends. But the same is true for Nvidia. You know, like I've reported weird issues with Nvidia, not as often as AMD for older games. But what I've noticed is Nvidia typically tends to take an action more quickly, and I think it's a resource thing. Like in my experience, I think that the difference is Nvidia is a bigger company. They have more resources to dedicate. They have way more software developers than AMD. So it makes sense from a resource standpoint, like in terms of time to resolution, you would hope that the bigger company can resolve the issue faster than the smaller one, right? Because then if it's the other way around, then the smaller one makes the bigger one look really, really incompetent. So... But yeah, I think in the professional side, I think Nvidia is really, really strong because of CUDA, and CUDA is a proprietary thing. And I tend to not advocate for proprietary technologies, but at the same time, I don't dislike them, because if I have to do something, and if a proprietary solution can resolve that task for me, then I'm not going to not use it, if that makes sense. So the fact that Nvidia has CUDA and AMD doesn't, and you have to fall back on OpenCL, which is fine. You know, it's one of those things where I can see why Nvidia is more likely to carry a kind of mindshare halo effect, just because if you look at like what their GPU supports, you know, not only does it support all the open stuff that AMD supports, but they have all this proprietary stuff like CUDA that AMD doesn't have. So, but the thing is, AMD, it's not like AMD is doing nothing about that. I don't know if you're familiar with ROCm. ROCm is the acronym, but they have been working on methods to translate CUDA so that they can work with an AMD accelerator or a GPU. So it's not like they're not doing that. And in the same time, in the data center world, when we're talking like EPYC versus Xeon, AMD has been encroaching on Intel big time in a very similar fashion when it comes to like VMware and the collaboration they're doing on that side. So yeah, they're investing a lot in the application space. So, which means that the leadership team under Lisa Su really is aware of where they're weak and where they're deficient, and I think that they're really executing very well in these areas. It just takes time to see these results, right? Like, just look at Zen 1. You can use that as an example. You can see how Ryzen has matured and come a long way for a company that was supposed to file for Chapter 11 bankruptcy in 2019, but it's now profitable. So, yeah. So when people hate on AMD, I just ignore it because I feel like they don't know what they're talking about. And the thing is, likewise, people like to hate on Intel nowadays, and I really don't know why. Because I feel like a lot of it is... It's weird. AMD has kind of become... It's almost like AMD has become the people's champion. Like, AMD is like Russell Crowe in Gladiator. And Intel is basically Caesar. That's kind of the way it looks in my mind, if I had to try to summarize it for someone who doesn't know what we're talking about. Right? Like, the perception of Intel has become so negative in a short amount of time, which is kind of mind-boggling. Because I remember when people used to hate on AMD... back in the bulldozer days, and then Ryzen came out, and people still kept buying Intel for the most part. It wasn't really until Zen 2, aka Ryzen 3000, Matisse, is when that really started turning the needle, because AMD basically did the whole, like, basically did the whole run back, right? Like, they did the whole redemption arc. They went from being at the bottom and clawed their way to the point where in 2019, when the 3900X and the 3800X launched, they matched Intel. They went from being behind until all of a sudden, Ryzen 3000 single thread was dead even with the 9900K from Intel. And then it only just kind of went up from there. Like, what happened, like, if we look at 2020, what happened in 2020? Well, Intel launched 10th gen and retook the crown from AMD in the middle of that year. But then we all know what happened at the end of that year. RTX 30 came out. It got scalped instantly. Then we had Ryzen 5000 came out, aka Zen 3. And they didn't change the chipset. It was still X6 or X570. But X570 became a mature platform, so it became X570S. S for silent, because they got rid of the chipset fan. And what ended up happening was, for the first time in like 14 years, AMD was back on top. Like Zen 3 beat Intel for the first time since 2006. AMD beat Intel in every measurable metric imaginable. Power consumption, they were better. Single thread, they were better. Multi-thread, they were better. Gaming performance, they were better. Application performance, they were better. They completely, like, defeated Intel in everything with the 5000 series. And that is the reason why people actually went out and bought Ryzen en masse. You had people waiting outside Micro Center to buy Zen 5 or Ryzen 5000. I don't think I've ever seen that ever happen. I can't stress that enough. Ryzen 5000 was probably their most successful launch in that company's history. Like, it was so smooth. There was none of these long post issues. There was none of this memory compatibility issues. Everything just kind of worked. It was a mature platform. The performance was there. It beat Intel in everything. It was more energy efficient in everything. You know, so that's the cool thing about the Zen 3 story. So how did Intel respond? What's fascinating about this is, what did Intel do? Well, they launched 11th gen, aka Rocket Lake, in May of last year. A lot of people forget that 11th gen is newer than Ryzen 5000. And guess what? It failed. It was probably Intel's worst launch in the company's history. It was more power and it was less performant. Not only did it lose to AMD's 5000 series CPUs, it also lost to Intel's 10th gen in certain scenarios. In some cases it was faster, but in a lot of scenarios it was worse. It actually lost. So Intel lost to AMD and they lost to themselves. So it looked kind of weird. It was almost like Intel had a bulldozer moment. Yeah, the Zen 3D. So Intel, what did Intel do? They basically had to double launch to try to redeem themselves, because Rocket Lake was such a failure in the spring of 2011, or did I say 2021? So last year, that in the fall of last year, so November 4th of last year, they go and they launch Alder Lake. 12th gen is here immediately. It's like, we're here, touchdown, and then it's like, they fixed it. Alder Lake kind of fixed it. Now, there were a little bit of eyebrow-raising stuff going on because, for example, if you want to actually benefit from Alder Lake, you need a couple things. One thing, you need Windows 11. If you don't have Windows 11, Alder Lake isn't really all that great. I'm using Alder Lake on Windows 10, so guess what? I can't use Intel Threadripper. It doesn't work on Windows 10. There were all these issues with certain games not working because the DRM client thought that you had two CPUs or you were hacking or something, so the game would crash or fail to launch. I know Soul Calibur didn't work for me. Code Vein didn't work. There were some other games that had to get patched. And then the other thing too was sometimes the E-cores could cause your games to crash after an extended period of time. Case in point, Final Fantasy XIV Endwalker launched in December of last year. I played it. I had to wait over an hour to log in because the queues were enormous. I get in, I play for 2 or 3 hours. You know, like all of a sudden I'm running on my Chocobo trying to find my ether current so I can fly in that zone, and bam, DX fatal error, crash a desktop. What's going on? And I'm thinking, oh great, this has got to be a memory. It's probably the memory's not stable or it's an Intel problem. So I thought, okay, maybe it's an E-core slash P-core problem. So what do? Go in the BIOS, turn off all the E-cores, turn them all off. So I gimp my PC, or I gimp my Intel 12th gen 12700K, so that it's only an 8-core 16-thread CPU, making it equal to a 5800X. And guess what? Problem solved. No more games crashing. I turn off all my E-cores, and then no more games crashing. So thanks, Intel. I can't use my E-cores. You basically sold me 4 cores that are useless. So I assume if I'm on Windows 11, that probably won't be a problem, because Threadripper will know to push the game engine threads onto the P-cores and keep them there. I think what was happening was every now and then the E-cores, like some of the game tasks would go to the E-cores, and for the most part that's fine. But I have a feeling that there's probably every now and then there is like a silent error that happens because the E-core is slower to respond than the P-core, or you get a race condition where something doesn't match. The P-core sends something too quick, and the E-core sends it a little bit slower, and the game server's like, out of order, and boom, game crash. There you go. Thanks, Intel. So, yeah, I mean, I plan to get the 13900K. It's a 24-core, 24-core, 8 P-core, 16 E-core. I don't know if that's going to fix the issue, but honestly, if I have to turn all 16 E-cores off so my game doesn't crash, that's going to be very, very disappointing. Because I plan to upgrade from the 12700K to the 13900K and see how that compares with this 7950X. I still have the box right here, actually. Ryzen 9 7950X, so right there. But yeah, I'm gonna be. The reason why I'm doing that, people are like, why do you need to buy that Intel CPU if you already have this? Just for comparison, I have two PCs for redundancy. The other thing too is the Intel 13900K is a 32-thread CPU, so it is equal to the 7950X in the thread count. In core count, it sounds like it has more. Why ask why? Well, because people are probably like, well, you already have like the flagship AMD. Why do you need the flagship Intel? You're waiting for AMD Ryzen 7000 price cut, then I'm getting 7600. I mean, honestly, if I was looking at the 7600X, because I actually know some people that are looking at doing that. They're thinking they're gonna wait for either the X3D for next year, or they wait for price cut. Now the thing is, like, here's what I would suggest. Since November is only like since Black Friday is only what, like almost 2 months, little less than 2 months away. Here's what I would do. I don't think there'll be a lot of price cuts on the 7600X. But I think during the holiday shopping season, you'll probably see, like $10, $20 price cuts on it. And I think you'll be able to potentially snag one for probably $20 off on Newegg. But I think where you'll be able to save is on DDR5. Because I have a feeling that during the holiday season, you're going to see some pretty decent deals for DDR5. And maybe the motherboards, but I would recommend B650, B650E. Go with B6. If you want PCI Gen 5, get a B650E motherboard. Don't get an X670 or X670E motherboard unless you really, really need it for like production work and stuff. If you're just trying to build a gaming PC, and typically if you're looking at the 7600X, I assume you're looking for a gaming PC. I really think that you'll be best served using the B. Let me go back here. Where is this thing? AM5 explained. You'll be better off with one of these because you'll still get this full allocation. Oh, they'll be cheaper because they're a single chipset, right? Like they're only gonna come with one right here, as opposed to 2 right here. So you're, in terms of the cost to manufacture, the B650 is significantly less. It's more in line with what we're used to seeing from the past. And it's still giving you the, okay, if you're good with PCI 4, then yeah, then just get a B650 board. But see, I really think that that's typically the gamer board, like, for gaming, for esports, for League of Legends, for Fortnite, for even, like, Cyberpunk 2077, Final Fantasy 14, any kind of MMO, New World, all that stuff. I would recommend, or Genshin Impact even, like, I would recommend one of these, like a B650 board. If you don't care about Gen 5, then just get a regular B650. That'll save even more money, because you don't have to pay for the PCI 5 bus. But yeah, I think, I guess, yeah, I typically operate on 2 desktops, like a backup and a primary. That's why I have 2. And it used to be Threadripper and X670, so Zen 3. Then it became Intel Alder Lake plus Threadripper, because Threadripper is really, really solid. Like, it's going to be really, really hard to move someone off Threadripper who's already on Threadripper. Now this computer that I'm using right now, so my new AM5 computer, this has replaced Threadripper. So my Threadripper computer was getting pretty old. That thing was, 2950X, 16 core, 32 thread, same as this, but it was only PCI Gen 3. It doesn't support resizable bar, and that was probably the biggest thing for me. There was no resizable bar, PCI Gen 3 only, and the Threadripper CPU itself wasn't good in a lot of, like, gaming, and even in production. Like, when I looked, what convinced me to get this upgrade was the fact that if you look at the benchmarks for the 7950X, it is almost 2x the Threadripper CPU that I used to have. So the 2950X that I upgraded from is almost it's almost a doubling in performance going to this new platform. And I'm getting Gen 5, I'm getting all that, the new platform that comes with that. And the lane allocation, all this stuff seems pretty good from what I can tell. So I do think anyone who's on X399 or Intel's X299, I feel like this is a really good upgrade. Like, it's a good happy medium between going to this as opposed to, like, going all the way to Threadripper 5000. Because I looked at Threadripper 5000, but I cannot justify spending $100 per CPU or per core, because that's what Threadripper charges. It's $100 per core. So, like, a 32 core Threadripper is $3,200, and that's just the CPU. And the motherboard is almost like $1,000. It's like buying the Extreme, the ASUS Extreme, only it's for Threadripper. It's like, that's like almost that, and then the memory. Well, the memory I wouldn't have to buy because I just carry over my DDR4, so that would save some money. But you're still looking at $4,000 for a computer upgrade, as opposed to this, which was $500 for the Gigabyte board and $700 for the CPU. So, $1,200 versus $4,000. Plus memory. Even the memory only cost me like $200. So, okay, we'll call it $1,500 with tax. $1,500 for Zen 4 and AM5 versus $4,000 for Threadripper 5000, Threadripper Pro. Yeah, it makes sense, right? Like, even if I were to drop down to the 24 core Threadripper, still not worth it. Still gonna be way too much money. $2,400 for the CPU? No. And people thought that the 4090 was expensive. So, but yeah, this was a good upgrade. I'm satisfied as long as I know eventually they'll fix these issues that I've run into. The post times will get better. Everything will just get better over time, because, Zen 1 was the same way. If I get a B650 motherboard, is it okay just to use one stick? Yes, actually, because DDR5 is kind of like it's almost like there's two DIMMs on one actual PCB. So it's actually okay. It's still not recommended, but it's better than like one stick of DDR4. Because I'm running 2 sticks right now, and in CPU Z, it shows up as, well, actually, let me see if I can show you guys. Let me see if I can share this and show you guys what this does, or what this looks like. Let me just make sure I have the right application here. Okay. See if I can add this as a source. Okay, so here's my CPU Z. So you guys can see, why is it here? Let me just move that there. Just put that in the middle. Okay, so this is my computer. So you guys can see I'm running a Ryzen 9 7950X, codename Raphael, max TDP 170 watts, socket AM5, LGA. So, oh, the other thing too that I want to point out, and this is very, very good about AMD, these new CPUs. So these CPUs support AVX 512. Now, I have Alder Lake. Alder Lake at launch also had AVX 512 support, but for some reason, Intel told the motherboard manufacturers to update the BIOS to remove AVX 512. So basically, I lost AVX 512 support on Alder Lake. If I wanted to get AVX 512 on Intel, I would have to go by Rocket Lake. So you know how everybody hated on 11th gen Intel and called it a waste of sand, and it's awful, it shouldn't exist, it's terrible? Well, the one redeeming thing about Rocket Lake is that it actually has AVX 512. And they, as far as I know, they never took it away. It was always meant to be on that CPU. So that's a little bit of trivia. Intel 11th gen has AVX 512, and Micro Center's got a whole bunch of them in stock. So it's probably going to get harder and harder to find one of those motherboards, though, because you need a Z590. But yeah, 11th gen is AVX 512. 12th gen used to have it. My CPU still has the functionality, but I would need to purchase an MSI Unify, a Z690 motherboard that still has the BIOS that supports it, if I wanted to have access to it. I know that it got so bad that Intel, because MSI defied Intel literally started chopping off the AVX 512 block, so that the newer 12th gen Intels you cannot enable AVX 512 at all, because they've removed it. Like, it's physically gone. So I'm not getting rid of my 12th gen 12700K anytime soon, because it still has it, but I just need a board that can support it. But anyway, okay, mainboard with a. Well, some people still like the PS by 2 interface for their keyboard, so that's why, because they want the direct interrupt. So that's why it's there. Actually, yeah. But you can see AVX 512 right there, supports it. And then if we look at the main board, Gigabyte AORUS Master. There you go, X670E. The BIOS, I did downgrade it to this BIOS F7D. F7E, I don't know if I'm going to go back to it. I don't know why my mouse is showing up like twice. That's really weird. Oh, I know why. It's because it's physically there, but it's sharing it that way. That's strange. Anyway, the memory, 32 gigs of DDR5. We're running it in a 1-to-1 ratio. But this is what I wanted to illustrate for that question earlier from Smoking On. You asked about is it okay to run 1 stick of RAM. So this is why I wanted to show CPU Z. So the channel 4x32-bit. So I'm running 2 DIMMs, and it says 4 channel. Numbers of channel, it says 4. So if you have 1 stick, it will say 2 channel. So this is the reason why it's not so bad to run a single stick of RAM on AM5 or DDR5. So you can do that, and it shouldn't be that much of a problem. See, so my memory is G.Skill, the actual Samsung. It's Samsung. Basically, the way you can tell if it's Samsung, typically if the Expo profile or XMP if the cast latency is the same as the RAS and the TRAS, or not the TRAS, but if the RAS and the cast RAS are all the same as the CL. So for example, 36, 36, 36, there's a very high probability that you're on Samsung memory. If the cast latency is different from the RAS and the RAS to cast, then, meaning, like, for example, I have 64 gigs right here of DDR5 that I do plan. These are two 32 gig DIMMs. This is Hynix memory. But this one, the timing is 30, 36, 36, 89. So this one has better timings, and it's a denser DIMM. This is 64 gigs of memory right here. I do plan to go back to this once we get a more stable BIOS, because I was running this solid at 5600, basically the XMP profile. This is not Expo memory, this is XMP memory, but I was running this with the XMP profile day one with the new Zen CPU, and it worked fine. Like, it was completely stable. The only thing is the post times are long, a little bit longer, like 10 seconds, 10-15 seconds longer to post on the initial training versus the 32 gigs. But, Hynix versus Samsung. And from my experience, Samsung memory has always played very well with Zen CPUs. So it's no surprise to me that this Expo rated memory just so happens to be Samsung memory. But the point of me saying all this is that if you're looking for memory to pair with Zen or with the new CPU, and you've never bought DDR5 before, I highly recommend that you buy memory that is Expo based memory. So Expo, that's the AMD, I guess it's like Extreme Performance Optimized for Ryzen, whatever the acronym stands for. Basically, it's meant to go with Ryzen. I recommend buying that over anything that says XMP, because the XMP stuff, it might work, but it's not guaranteed. If you were buying XMP memory, you have to check the QVL list. But even if you're buying Expo memory, I would still check the QVL, so the qualified vendor list on the motherboard website that you're looking at. So for example, let me go ahead and take this away because we don't need this anymore. So if we're buying, like, for example, let's look at this AORUS. This AORUS Elite AX memory support list. So right here, see how they're showing all the different SKUs? Like, this is all memory that is compatible, or like what this means is that somebody at Gigabyte actually took this memory, plugged it into this motherboard, and with these settings, with these timings, with the number of DIMMs, with the capacity and that speed, they were able to get it to run as advertised. So if we look here also, notice how this is Hynix. Actually, let me zoom in because it looks kind of small. Why are they not? Okay, whoa. Okay, this is better. So you can see Hynix. Notice 34, 40, 40, 105. Notice how the first number is less than these other two numbers. So that usually means it's Hynix. Not always, but there's a good chance that it's Hynix. So see how these are all Hynix? If we go and look until we find... okay, so this is 40, 40, 40. That could be Samsung, but it is such low... or it's such high latency, loose timings that... but it's 6400. And usually if it's 6400, it's going to be Hynix. But let's try to find some Samsung. These are all Hynix. Okay, there we go. So notice how, like, Samsung, it's typically always the first three numbers are almost always the same. Like, that's the thing I've noticed. So like 40, 40, these are all like the, okay. See, right here, 36, 36, 36. That's Samsung. 36, 36, all 40, 40, 40. But notice here, 30, 36, 36, and it's Hynix. This is what I was saying earlier. 36, 36. So if the three numbers are the same, and assuming we're not talking about cast latency of 40, because that's pretty loose timings, it's usually going to be Samsung. And if it's a lower latency on the cast latency, it's typically going to be Hynix. Not 100% guaranteed, but from my own observation, that's what I've noticed in terms of the pattern. Like Samsung usually has the same three numbers for the primary timings. Hynix has the first one usually lower. So Hynix, what that tends to mean is that Hynix is probably going to perform better. And especially as you go up the stack in terms of the speed, in terms of the mega transfers, Hynix is going to be more at the higher end of the market. But I have noticed that historically Samsung has played really, really well with Zen CPUs. Like the IMC of Ryzen works really good with Samsung, or Samsung's able to tolerate better. We'll put it that way. Samsung's better at tolerating the tantrums that can happen with Zen's IMC. So that's why it's no surprise to me that this Expo rated kit is Samsung memory, and this non-Expo kit is Hynix memory. But the Hynix memory works fine. So, but just keep that in mind. I mean, this is the kind of info that like people typically aren't really gonna know. Like if you go watch a reviewer's video, if you go watch like Jay's 2 Cents or someone, they're probably not gonna talk too much about stuff like this because this is way too technical. And they don't have time to devote to this type of content. So this is more for people like either myself or maybe someone like BuildZoid. I think he's already done videos on memory in the past. But like this is the sort of stuff that you won't really find from what I consider the mainstream media outlets for tech stuff on YouTube. But yeah, if you're gonna go with if you're gonna build a gaming PC, and you're looking at Ryzen 7000, like a 7600X, I recommend a B650 board and Expo memory kit. Two 16 gig DIMMs for a total of 32 gigs. Early days, I would say 32 gig DIMMs. If you want to go 64, you can do that, but just make sure that you don't go above 6,000 mega transfers, because I think you're going to have trouble running 64 gigs at 6,000. Aim for 5600, because I can attest to 5600 on 64 gigs working perfectly fine with my setup. So I know that works, but again, it kind of depends on the motherboard. It depends on the memory controller. 4800, yeah, 4800 is fine. 4800, if you're going to run 128 gigs across 4 DIMMs, 4800 is kind of what you're gonna aim for. Like if you can get above 4800 at 128 gigs of RAM, that means you have a very good CPU. Because a lot of the memory compatibility, it isn't so much the motherboard. The motherboard does matter, but I think the IMC in the CPU, or the integrated memory controller inside the Ryzen CPU, matters more. Because if you got lucky and you got a strong IMC, because it's silicon lottery at the end of the day, because all these speeds that are above 5200 are considered an overclock. So if you're able to run, like 64, well, if you're able to run 128 gigs of memory at 4800, that's ideal. You shouldn't even bother to try to go above that, because I don't think every CPU is guaranteed to do that. In fact, I think AMD, on AMD's website, I think they say 3600 mega transfers for 4 DIMMs where they're all dual rank DIMMs. That's like the worst case scenario. They're claiming 3600 is the speed, but if you can manage to get 4800, that's considered an overclock for that kind of density. So that's really good. That means that you're actually able to pull off 128 gigs at an overclock, what's considered an overclock speed, for the CPU. But you'd have to test for stability, because I wonder if that's going to be 100% stable. Maybe with, you know, like a 1.25 volt on the VDDC for the RAM. Maybe. We'll see. I don't have 128 gigs to test. I would test and do a video on that. In fact, I might do a video, like an actual YouTube, not a live stream, but I might actually do a YouTube video on memory compatibility for Zen 4. I'll show XMP, you know, memory that's supposed to go with Intel. I'm gonna run this. I already know it works, but you know, I'll show how it differs from AMD Expo based memory, and what to look out for. I might do a video on that, but I think in the coming days, if I can get Intel Arc, I'm gonna be doing a lot of videos on Intel Arc, paired up with either Ryzen or Intel, and then I'm probably going to do some coverage on Intel's 13th gen, the 13900K, what the experience is like using a more mature platform, because Alder Lake was pretty terrible in terms of games not working because of DRM issues, Windows 10 not being able to use Threadripper at all. They've made improvements to Threadripper, but I'm still on Windows 10, so I'm not going to see any of those improvements. So who knows? You know what I want to see from reviewers is I want to see a review that shows Alder Lake. Oh, not Alder Lake. When Raptor Lake comes out, I want to see Raptor Lake tested against Ryzen and the older stuff on Windows 10. I want to see how it performs on Windows 10, because no one seems to cover Windows 10 that much anymore. They always try to paint things in their best light, which is, I guess, how it should be. But, you know, it would be nice to see how it performs on older operating systems like Windows 10, because I still think that the vast majority of Windows users are on Windows 10. So if 13th gen, like the way I see it, this is what I expect is going to happen. I think 13th gen will win against Ryzen 7000 in single core, and then as a result, in most multi-threaded workloads, I expect Raptor Lake to eke out a win, because essentially it's going to be 16 E cores plus 8 P cores versus, you know, 16 essentially P cores from AMD. So it's 24 cores versus 12 or 16 cores, right? So at the end of the day, Intel has an advantage, but how much of an advantage that is, I don't really know, because those E cores are not that good. They're like Skylake cores. As far as I know, they didn't change them. They did make some changes to the P core. So Golden Cove was the Alder Lake P core. I think this one's called Raptor Cove. And then Gracemont is the E core, and that didn't change. You're still using Gracemont. There's just more of them. So we'll see how that goes. I think it's going to be very, very interesting. But what I think is going to happen is, I think in Windows 11, I expect Intel 13th gen to beat AMD at the high end. Well, I mean, even at the mid range too. But I expect Intel to win, especially in Windows 11. Now, where it gets interesting is Windows 10, because in Windows 10 you don't have access to Threadripper. So it's like now they're both competing strictly on the hardware. So how well that changes the results, I don't know. Like, it might make Intel perform worse, but then the thing is, like, how much of a lead do they have to begin with? So it's like, you know, maybe they're the same. Maybe AMD actually wins more in multi-threaded workloads on Windows 10 because Threadripper doesn't know what to do, or Windows 10 doesn't know what to do with those E-cores. You know, stuff like that could happen. I don't know. It could also affect gaming performance, because if you have so many E-cores, the probability that Windows 10 just starts assigning things in the game engine randomly to the E-cores goes up, because 2/3 of your cores are now E-cores. So that could actually hurt the 13900K compared to the previous 12900K, where half the cores were P cores and half the cores were E cores. Now it's a little bit more unbalanced. There's too many E-cores now. So I think it'll be interesting to see how that plays out on Windows 10, because maybe Windows 10 you might see some performance degradation happen on the i9. But only reviewers can show that. I mean, I'll be able to test it myself if I actually decide to get the chip. I haven't 100% committed to buying 13th gen yet. I'm definitely not going to change my motherboard. So I am going to use the same ghetto Gigabyte motherboard with the DDR4 with Raptor Lake. Which is nice, because it's interesting, right? Like, for once, Intel is a drop-in socket upgrade for me, and whereas AMD, it was the complete opposite. I had to buy a new motherboard and new memory. So, alright guys, well I think that's pretty much where, I think that's a good place to end the stream. I think I covered a lot. I went way over what I expected to do. But I do think we did do a lot of discussion on the chipset, the layout, B650, X670, as well as we talked about Alder Lake. I'm going to try to get not Alder Lake. We talked about Intel Arc. I'm going to try to get that A770 limited edition. I don't know if it's like only going to be Newegg or if Microcenter will even have those. I need to look into that. And then hopefully I can somehow get MSI Ace motherboard, unless Gigabyte gets back to me and confirms that they're going to be able to fix this issue in the next couple of weeks. But anyway, that's a good stopping point. I guess I'll just thank everybody who participated in the chat. I like the comments. There was really good discussion across the board. And if you're looking at hardware and you have questions, you can leave a comment in this after the stream. I'm going to probably chop up the video or chop up the stream into different videos based off of the topic, and then kind of put those as separate segments. So anyway, guys, if there isn't anything else, I'm going to go ahead and close out the stream. And again, I appreciate everybody for participating and just watching, and I will catch you guys in the next one. We'll probably be back with... if I can get one, we'll be back with an unboxing of the upcoming Intel Arc A770 limited edition. And with that, alright guys, thanks and have a good weekend. Take care.